Welcome back, everyone, to the second day of Global Spectrum Management Forum 2022. Thank you very much for being here with us today. We have so many participants here on site as well as online. And I would like to especially introduce our overseas participants who are joining us through the Zoom. Shall we wave our hand to our online participants who are joining us through Zoom? Yes, could you please wave your hand, everyone? Thank you very much. Thank you. Even though we are miles apart, seeing everyone's faces through the screen, we feel so much closer. Thank you very much. Please stay with us until the very end. Now we'll proceed to the session 3 under the title of Recent Technology for Spectrum Management. And the session will be moderated by Mr. Chung Hwan Hwang. Mr. Hwang is Director of Electronics and Telecommunications Research Institute, and currently he's researching EM exposure from 6G EM wave and service technology based on satellite, and has researched on channel modeling of body area network and developed a power amplifier used for handheld phone. Ladies and gentlemen, please welcome him with a big round of applause.
Hello, everyone. Thank you for a nice introduction. Before coming here, I looked over the sky by chance, so I could see a very big blue and high sky today. So, according to one of the Korean old saying, it said that fall is the season when the sky is very high and horse get pet. So it is harvesting season. So we have plenty of grass and vegetable and fruits and so on. So we can feed horse to get it bigger and bigger. In addition, we have a very blue sky at this time, so I recommend you to go outside and look over the sky during the short break time. So anyway, it's time to start to our second day. So yesterday, we talked about the current status and current trends in spectrum monitoring management. So now is some time to talk about next. What will the spectrum monitoring be in near future? So that is a very interesting topic to many people in the world. So I am definitely sure that today's talk are very helpful to you and to many people online also. So let us start our second day in session 3. So the first presenter is Mr. Sangbong-yun, Mr. Sangbong-yun, I'm sorry. He is working with LIG Next One in Korea, and his position is Chief Research Engineer. So the presentation title is Monitoring and Direction Finding. Direction finding. So let us give some big applause to Mr. Yoon. Where is Mr. Yoon?
Ladies and gentlemen, thanks for warm welcoming today. My name is Sangbom Yoon. Sangbom Yoon, yeah. I am going to make a presentation about monitoring and direction finding technology and systems. At first, I'd like to introduce our company, LIG Next One. Since founded in 1976, we have developed command control and communication devices and avionic electric warfare system weapons. Now, recently, we are developing unmanned equipment like a drone, robots, AI, cyber, radio monitoring system, and anti-drone. Today, my presentation consists of 4 parts. Number 1 is radio monitoring systems overview. And second is fixed and mobile radio monitoring systems. Third is next generation technology. The last is conclusion. I think some of you are interested in monitoring and direction finding technology as it is. The thing is that we have developed and we have reached to the highest level for them in Korea. So today, I will explain that how to make use of them effectively. Where should we go forward in next generation? Number 1, system overview. Radio monitoring system contributes to clean radio environment by detecting localization and dissolving the interference, jamming, illegal signals, waves. Here, system overview is the following. Expansion of measuring radio frequency. Frequency ranges for direction finding is 20 megahertz to 7.5 gigahertz. Measurement frequency is 9 kilohertz to 7.5 gigahertz for fixed, up to 40 gigahertz for mobile. Second is automatic intelligent radio monitoring. Third is intelligence for radio management. Final is the application of new IT technologies applied to third generation radio monitoring system. From now on, I'd like to show the third generation monitoring systems. Fixed system configuration. Fixed system can monitor all signals around the fixed system and enlarge the coverage with very low sensitivity than mobile systems. Mostly, the system is located on crowded and highest place in the city. The fixed system is installed on the tower. On the picture, you can see. And consists of measuring antenna with various band and direction finding antenna, GNSS antenna. And on the right picture, you can see the measurement, direction finding receiver, monitoring receiver, demodulation receiver, GNSS receivers. And to manage the radio monitoring system, we have FMS. On the other hand, mobile system can monitor the signals and homing the target thanks to mobility. Mostly, the system is operated with the connection of other fixed system or mobile system. The mobile system consists of direction finding antenna on the top and measuring antenna on the roof. Up to 40 gigahertz we have. And on the right picture, you can see the various receivers. Monitoring and direction finding technology enables this system to capture the signal features and to get the result from the receivers. And the system can display like this: broadband spectrum, radio quality measurement, frequency utilization survey, and analysis of illegal radio investigation, analysis of radio noise measurement, analysis of radio quality results. Now, direction finding comparison. Previously, I told you we have reached to the higher level in direction finding technology. There are several methods, TF method, using amplitude, phase, time information. But now, to get a better result, we have used all information combined with the amplitude, phase, time difference for high confidence. Still, direction finding is weak. To multipath environment, humidity, weather, tree, any other obstacles. In Korea, surrounded by many mountains and buildings, it is influenced more than other countries. Therefore, we install several TF stations and get TF result, analyze the result, and finally we pick the one LOB by statistical spatial method and follow the emitter. We can have the best solution in any situation. On the table, I summarized the TF method by antenna type, feature, signal duration, and so on. Nowadays, music is the most used type. In the middle, recently, when it comes to drone, many people are interested in drones. So, drone detection and direction finding is getting more important. For that, we expect that music and Esprit could be used. Let's move on next generation technology. With the development of communication technology, it is convenient for us to communicate and control IoT device. The quality of our life is getting better. But on the contrary, smart, intelligent illegal radio signals is going to be increased. With the legacy equipment, we can't detect and follow the illegal signals. It is essential to build a clean radio environment with more advanced monitoring technology, promoted with state-of-the-art AI and big data. I think next generation technology is the following. Number one, virtual narrowband receiver technology. Second is scalability to increase the performance. Third is advanced post-signal analysis to get more information get more information from the recorded data. Number 4 is the hybrid TDA with drone to enlarge the coverage. Yeah, number 1 is virtual narrowband receiver technology. Simply, the technology is one wideband receivers is operated as they have several hundred narrowband receivers. So all operation like detect, demodulation, direction finding, classification is done simultaneously. Simple structure make it out of breakdowns. The most important thing is that all signals in bandwidth can be detected and saved, analyzed, demodulated, monitored simultaneously. Second is scalability. VNR could be added to the system, like on the right picture, VNR add-on. It is enhanced and is operated like one system. That is, more signal is monitored. On the right picture, you can see the VNR add-on like that. The system could be enhanced their performance as you want. Next is advanced post-signal analysis. In real-time operation, wideband IQ data is recorded. Later on, from the IQ data, we can extract waterfall, level, frequency range, DF result, modulation type, time information, etc. in semi-real time. The extracted data can be used to metadata analysis. It will be useful to detect the sign effectively, predict illegal signals, pattern, target moving path, and so on. Some of them would need long-term analysis. For drone control signal, as you know, drone control signal is very complicated. Fast frequency of, short duration, long pattern. So it is easy to miss the signals in real-time system. In that case, we need post-signal analysis. Many drones have their ID and patterns. In case that you are interested in the signal, you should check first drone's ID in every hop. For that, powerful bit stream analysis could be helpful. Finally, is hybrid TDA technology with drone. Usually fixed or mobile system installed several sites in the city, so they can't cover all area of the city. Especially for mobiles, they have disadvantage not to approach to destination in time. In that case, drone could be useful to reach to the destination quickly. Drone enlarge the coverage or systems and fast approach to the target. On the right picture, drone TDA, fixed DF, AOA, mobile TDA. By hybrid TDA, they captured target, finally. Here is the last conclusion. I can't agree more. Third generation radio monitoring system is the most suitable configuration for the fixed mobile monitoring system. It has been installed and operates since it developed. Maybe 2 or 3 years later, all system will work in Korea. I think it will work and contribute to clean radio environment in Korea. For next generation, I think next generation technology could be VNR, post-signal analysis, metadata analysis. Thank you for listening to my speaking. I hope you understand monitoring and direction finding technology and what next generation is. have a good time. Thank you.
Thank you for a nice presentation, Mr. Yun. First of all, I am sorry for calling you in a wrong way at the beginning of this presentation. So I think I am already old because it is not easy for me to read a small letter on this paper, especially under very bright light. I am sorry about that. So let's move on to the next presentation. Its title is Neutralization Technology to Counter the Threat of Drone Terrorism. So it will be presented by Mr. Shin Jae-sik. He is working with the Samjang solution in Korea, and his position is general manager. So let us give him a big applause to welcome him.
Present here and abroad today. I am Jae-sik Shin from General Manager of Samjang Solution. My topic is neutralization technology to counter the threat of drone terrorism. The contents are as follows. First, I will tell you about the threat of drone terrorism now becoming a reality. After that, the characteristics of illegal drones and countermeasures against them, and the technology and equipment that can be neutralized them. Finally, I'd like to make a few suggestions. As you might see in the news, in 2014, 3 North Korean drones were found crashing. There was a similar news in 2019 again. Our government, Ministry of National Defense, confirmed that takeoff and return point of all 3 flights were in North Korea. Their coordinates entered to move over a number of military facilities in advance. Recently, a drone that crashed at an LNG base was also discovered. It has been identified as a privately made product without a prior flight permit or even a unique identification number. The arrested operator insisted that it seemed that crashed in a lot of wind during the club's activities, and there was no purpose for filming. As we have seen in these 2 cases, there are many changes in the implications of drones. When drones were first developed and started to be used, most people had mainly concerned about illegal filming. As widely reported in the international media, nowadays it is beyond being used as an attacking weapon for human life. It is evolving to the point as the main means of war or terrorism. There are some common implications here. First, from the security manager's viewpoint, there are many concerns that cannot be solved in the field. Seeing the previous domestic accident cases, is the drone found crashed is a simple mistake? How much more will there be not discovered? Whether the act is unlawful or not, whether it invaded or not. Measures are appropriate and there are no issues to be held accountable for, etc. You will ask yourself whether it is appropriate to emphasize that they must make a status report after the preemptive in advance. I don't think so. There are a lot there are a few issues needed to be addressed in advance. What I'm going to talk about today started from this point of view. In addition, from the system developers' viewpoint, there are also a lot of issues needed to be solved. New technologies and methods, related laws and regulations, etc. I think the most important thing is to communicate with relevant organizations to find the most suitable anti-drone system. As you know very well, because drone in general have some characteristics, such as easy to operate, stable hovering, obstacle avoidance, etc. Their uses are widely spreading across the industries. On the other hand, despite the vulnerabilities of being affected by wind and the short flight time, it can be used for terrorism, direct attack in short range, and medium and long range attack using GPS. There is also a clear difference between general infiltration and illegal drones. As a rule, infiltration attacks on personnel and supplies is a two-dimensional, horizontal, and unidentifiable. On the other hand, illegal drones are three-dimensional, autonomous, or remotely controlled flying objects, can maneuver vertically and horizontally in high speed and cannot be identified, except in short distance. As a result, the concept of response is bound to be different. Criminal activities using drones can take many forms, such as direct attack, smuggling, criminal acts, and so on. Various techniques and methods are being used to counter this. To respond to the threat, our government is investing approximately 42 billion won to develop intelligent illegal drone response technology, shown in the picture, by 2025. If it detects illegal drones in the flight restricted area initially, then neutralize them step by step using several systems, finally investigate and analyze them. But the question is, are there no realistic alternatives before 2025 when development is complete, and whether the investment for anti-drone system should be postponed until then? I don't think so, because drone terrorism might happen anytime, any place. The government is amending relevant laws and regulations, especially the Radio Waves Act and the Aviation Safety Act. Article 29 of the Radio Waves Act, as amended in 2020, states that 6 laws specify the exceptional case in which the radio blocker can be used, but inevitable for the purpose of security in the Presidential Security Act and the military activities, counter-terrorism activities in each related act. There are a few questions of how to interpret and apply to in detail. The same as in other acts. If it is not interpreted more clearly, there are many concerns for institutions that need to enforce the law in the facility. In order to operate the radio interference equipment, we should be familiar with the process of introduction and discard, the authorization of manufacture and import and sale. However, as in previous chart, although the law is well stated, illegal action in this regard of the law may occur in the future. The same goes for the Aviation Safety Act. Article 79 restricts flight in controlled airspace without obtaining prior permission. But there's no way to check if someone doesn't follow the act. Article 78 divides airspace. In case of regulatory airspace, it is necessary to prohibit or restrict the flight of an aircraft for the safety of air traffic. But there is no flight restrictions on ultralight vehicles. You're also supposed to report and have to obtain the flight approval in advance, but the scope of exclusion is 500 feet in altitude. Prohibited acts on board is not applicable if it is less than 1,000 feet in altitude also. Forbidden activities for the ultralight vehicle pilots are stated in detail also. Crimes of unlawful use and alternative fines are stated in detail also. However, the problem is that when discovered the drone flying fast, not following the laws, the security manager's concern is that judging is extremely difficult because whether it infiltrates and flies illegal or not is not clear, or whether the act is inappropriate or unlawful, etc. To continue, let me tell you the neutralization techniques and equipment. In general, the responding procedure includes detection, identification, and neutralization. Among them, I am going to focus on neutralization. Many technologies, countermeasures are being used to neutralize them. In addition to air defense weapons as a military countermeasure, there are hard-kill methods using physical forces such as eagle, nets, laser, EMP, etc. However, the use of eagles requires training, but cannot even capture cluster drones. The capture by nets is also the same. Lasers and EMPs are expensive, hard to aim. And if destroyed, there is a risk of second-degree damage caused by this. On the other hand, there are soft-kill methods not attacking the aircraft directly. However, the spoofing method has a risk of affecting GPS using equipment, and it cannot neutralize the operator's direct control, while this spoofing might violate the law. Among them, I will introduce mainly jamming as the best way. Jamming technology can force illegal drones to hovering or forcible landing. Because of blocking GPS signals simultaneously, it can prevent returning them to home. It is easy to use and effectively neutralize cluster drones also. Let me introduce some soft kill method by jamming. My company has a wide range of products that can be used for defending illegal drones from unauthorized shooting, explosive terrorist attacks, and security protections, etc. The portable type anti-drone gun shown in the figure covers the GPS L1, L2, and ISM 2.4, 5.8 gigahertz bands, and can jam up to 500 meters away at the same time. This equipment is certified as an excellent technology innovation product by the Ministry of Small and Medium Enterprise and Startups for the first time in Korea. It's 100% equipped with its own technology. In the last year alone, more than 100 units have been delivered to the facilities of government and affiliated agencies. In July of this year, our company registered 4 more products related to this. This equipment also being used to control the telecommunication signal of the police, military, and civilian within military border area. As you can see in the table, you can block a variety of frequencies from spillover. This equipment can respond to IEDs, improvised explosive devices, and can block 12 bands. It is mobile type with 2 hours of continuous radiation time. This can be mounted on field armored vehicle, providing military specification level. This can respond to multiple bands simultaneously within a radius of 300 meters as they move. Also, we have integrated anti-drone system. It can automatically detect, identify, and respond to all illegal drones. Radar, ER cameras, jamming, guns, and control system are all mounted in the vehicle. The system can be operated while on board, or can be fixed and operated on the ground after movement. So far, I have introduced the suite of drone and their characteristics and the equipment of neutralization. In order to further develop countermeasures, I want to make a few suggestions. First of all, in line with the development of drones, the government should supplement the laws and regulations and develop supporting policies for industry and need to hurry up standardization. Academies and research institutes must activate industry, university, institute collaboration programs and play a leading role in the development of new technologies. Efforts also should be made by demanding institutes by analyzing drone fleet and the characteristics of their facilities where it is needed to design more appropriate countermeasures and to have to budget to secure them and to build up step by step. Finally, supply companies also actively participate in government, university, institutions linkage programs and have to strive to develop integrated anti-drone system, high-low mix, and hard kill and soft kill, etc. In conclusion, considering the drastically growing drone industry, I want to reiterate that response to drone terrorism is a really important thing to do. I'm also convinced that the most effective way is to neutralize them by jamming, including efforts of government to ensure conditions through the revision of laws and regulations, etc. All research institutes, industries, and equipment adoption agencies should communicate and work together. That concludes my presentation. Thank you very much for listening. Thank you.
Thank you for nice presentation, Mr. Sin. He introduced several technologies to prevent drone. And also he explained the Korean law structure to deal with the drone issue in Korea. And finally, he made some suggestion to academy and research institute and industrial sections. So I think those suggestions are very useful for several parties in Korea. So thank you for Mr. Sin. We have another presentation related to drone. So the next presentation is title is the drone direction finding and identification system based on the object recognition technology. So this presentation will be presented by Mr. No Kyung-chan. He is working at Fifa in Korea, and currently he is team leader in Fifa. So let us give some big applause to welcome him.
Good afternoon, everyone. I would like to stand here instead of there because I borrowed new clothes for this GSMF. Okay, my name is Kyung-chan No. I'm the leader of the System Development Department in Fiaa, and now I currently work as a system engineer. Today, I'm going to present the drone direction finding and identification system based on object recognition technology. To start, I will speak about the background, why we developed the drone detection system, and then I will explain some general drone detection technologies. And for the last, I will introduce our drone direction finding and identification system. Let's start. As the previous speaker already said, the anti-drone has never been crucial before. So this article is about the accident occurred on the oil depot in Saudi Arabia. The Yemen's rebels attacked it with the drone and rockets. Unfortunately, there are some casualties, and the oil depot got some damages. And this picture is Incheon International Airport, the biggest airport in Korea. More than 50 million of people use this airport in a year. 2 years ago, 2 flights were diverted from the airport due to a suspected drone activity. Police found that the real estate agent was flying a drone to take their promotion video of their apartment. So drone can affect our daily lives, not only for radical situations such as military or terrorism. And we Fiaa, we are specialized in direction finding and spectrum monitoring. We've developed a spectrum monitoring receiver and also radio big data AI analysis platform, which is HiSuite. So we more focus on drone detection system among the whole anti-drone system. So now I will explain some general drone detection systems. The first one is EOIR. It's organized with 2 cameras. The one is optical camera, so you can see a drone with the camera, and the other one is infrared or a thermal camera, so they can complement each other. And the other one is radar. And radar have been a reliable and popular detection system for a long time. And the last one is, I'm going to more focus on this one. It's a RF detecting method. So it can detect a drone with the RF signal. Because drone communicate with the user or controller with RF signal, if we can detect the signal, we can find out there is a drone. And now we can see pros and cons of these systems. Because EOIR you can detect a drone with the camera, you can see how it looks like, or you can recognize it is drone or something else. But it can be affected by daylight or the bad weather. Also, it had a short and narrow detection range. And nowadays, many people are worried about an invasion of privacy. So I think it's not a good idea to use in the city. And radar, it has a wide and long range detection. Also, it has a good direction finding accuracy. But the way of working radar, it can interfere with other communication systems. Also, it has some problem to distinguish drone and bird. And RF detection method, it has a high accuracy of direction finding, and also it can detect a drone regardless weather or daylight. And it's less regulated, so it's more convenient to use in the city. But it has some problem to detect an autonomous drone, and also it has a low detection accuracy. And currently, most of anti-drone systems are used to protect government facilities. So it's a more comprehensive and high-priced system. But as drone use become more popular, the private demand also will increase. So, and as I said, EOIR and radar has some problem to use in the city. So we thought RF detection method has more advantages than other systems. Yeah. There are some technologies to find a direction of a drone in RF detection method. The one is protocol scanner. It can extract information by decrypting a drone protocol. So the user can get a lot of information, include the position data, and also that information is very accurate because it can get information from a drone directly, and also the detection range is pretty long. So it seems like a perfect system to detect a drone. But the problem is only a few of companies provide their protocol. And also, there is a risk to change or encrypt protocol again. And there are other methods to find a direction of drone, amplitude and comparison amplitude and page comparison. Amplitude comparison, it has a long detection range, but the direction finding accuracy is a little bit lower. And instead, the page comparison has a good direction finding accuracy, but because it uses omni antenna, it has short detection range. So we mainly use page comparison for direction finding, but we also try to take advantages of amplitude comparison method. So we try to complement these advantages. Okay, now I will introduce our drone detection system more. Do you know what factors are very important for drone detection? The long range detection and a good direction finding accuracy are very important for detection of drone. So to get a long detection range, the gain should be high and the noise figure should be low. So for that, we choose a directional antenna. Although omni antenna usually can be used for direction finding. Also, RNA is set after antenna, so the noise figure should be lower. And our RF receiver has designed with a low noise figure too. And for a good direction finding accuracy can be affected by multipath error. So to reduce that error, we applied a sector antenna. And also, 4 sectors antenna are each installed at an angle of 90 degrees, so it can cover 360 degrees. And also, our antenna is designed for drone band, such as 400, 900 megahertz, and 2.45 gigahertz. And about the data processing, we applied a correlative interferometer, which has a high direction accuracy. And also, the object recognition technology can increase the direction finding accuracy. Before we go more, it's better to know about the character of a drone signal. Drone can transmit a signal by time division. And also the frequency is hoping to avoid interference with other communication system. And also when drone transmits video data, it uses a wide bandwidth. And drone usually use a band 2.4 gigahertz or 5 gigahertz. Usually there are many other signals are mixed. So in this kind of environment, we thought the object recognition technology can help. So we analyze a spectrogram, and then the object recognition technology recognize a signal as an object. So the direction finding algorithm can find a direction of a drone efficiently. And also to detect a drone, the fast data processing is critical. So our object recognition technology can decrease the amount of data to process. So it makes good detection performance for our system. And also, do you know how many drones are in the world? According to a Grandview research, there are 372,000 of commercial drones are registered now. So it's very useful if you can identify a drone. And our system can do it. As you can see, every spectrum of each drone looks a little bit different. So we can identify a drone with the analysis spectrogram. And also, we applied a machine learning technology for that. So we collect as many data as we can. So the algorithm has studied with those data. So we could increase the success rate of drone identification. And our system also, we also developed our operating program. There are many useful functions, such as we can choose operating mode and bandwidth and data transmission speed. And also there are automatic or manual operating mode. If you choose automatic operation, it can search every band we can detect. And so any drone can be found with this mode. And if you want to search a specific drone quickly, you can use manual operation mode. Then you can choose a frequency or you can choose a brand of drone. And also, our system indicates the direction of drone on GIS map, so user can see where drone is easily. And also, because we developed our operating program, we can customize our program as user want. Okay, let's summarize what I tell you today. There are some drone detection systems, such as EOIR, radar, and the system which uses RF detecting method. And also there are some technologies to find a direction of a drone, which is protocol scanning and amplitude page comparison. And there are two points for a good detection system, a long-range detection and high direction finding accuracy. And for that, we use directional antenna and RF receiver, which is designed with a low noise figure. And also we use 4 sectors, 4 rays, and 4 bands antenna system. And we applied CI algorithm and object recognition technologies. Also, our system can identify a drone. So that's everything I prepared today. I hope you enjoyed this time. Thank you so much.
Thank you for your presentation, Mr. No. So he introduced the drone recognition technology that is based on radio frequency. So my small comment is that we can establish a database which is composed of spectral diagrams. So we can identify which kind of drone is in the air using that database. Anyway, thank you very much. And our last presentation is about radio jamming. The title is Technology for Radio Jamming Monitoring and Interference Signal Geolocation. So it will be presented by Mr. Kim Jun-won. He is working with Onpum in Korea, and his position is General Manager of Radio Management Solution Division in Onpum. So let us give some big applause to him.
A little bit different with this photo, right? Maybe 20 years ago, Thank you for a warm welcome, Mr. Hwang. And I would like to start with the say hello in Korea. 안녕하세요. Yeah, 안녕하세요. Good morning, and good afternoon, and good evening. I'm Junwon Kim from Onpum. I'm General Sales Manager of Radio Management Solution Division. I'm so humbled and honored to be invited to introduce the technology of radio jamming monitoring analysis and then signal geolocation. Before I move into the presentation, I would like to express my sincere gratitude to Central Radio Management Service, CRMS, and Korea Radio Promotion Association, RAPA. So let me start. This presentation is divided into the 4 sections. First one, I would like to introduce why the radio jamming monitoring system necessary. And then I will walk you through what the jamming monitoring system looks like. And then I will introduce what kind of technologies used in this system. And last but not least, I would like to summarize with some key takeaways. So nowadays, when it comes to the radio wave, it becomes increasingly crucial to vital national resources that determines the country's competitiveness and then digital core elements. So GPS, TV, and radio broadcast, mobile communication, and maritime and aviation frequencies are widely used in the people's their lives and safety. Have you ever heard that there's some instance about the mobile disconnection services, mobile service disconnections, and then some delays in the aircraft landing and takeoff at the airport due to the illegal jamming? And recently, as you already know, the Russia jammed the GPS signal that provided to the U.S. Ukraine. It affected not only the military service but also the civilian and the public services. Therefore, to respond to jamming on these important radios, it is necessary to take prompt actions with the help of dedicated 24/7 jamming monitoring system. So CRMS has already implemented several 24/7 dedicated radio jamming monitoring systems, such as GNSS and broadcast and communications. The system I will introduce today is the broadcast and communication jamming monitoring system, which can automatically detect, analyze, and determine the signal of the disturbance, and then all the processing steps, as you can see in the bottom, seamless process in 3 minutes without any human interventions. With that, this system helps the decision makers to take a proper counteraction by providing the estimated influence range and situation report and propagation on time. To fulfill all requirements asked, it's necessary to list up and analyze every function of blocks in detail and design how the task should work step by step, and finally get all things work together as you expect. The main processes we need to set up are jamming detection, direction finding, signal geolocation, and direction find the links with other jamming monitoring system. With that, the system can not only satisfy all the requirements, but also increase the efficiency and convenience in operation. The slide shows the basic configuration of the jamming monitoring system deployed for the broadband broadcast and communications, ranging from 30 megahertz to 3.6 gigahertz. This system consists of the radio measurement and direction finding system installed in the remote side, as you can see on the left side, and the operating system in the command control center on the right side. In the remote side, the system has a dedicated antenna for measurement and direction finding, and signal distributors, receivers, storage, and controllers as well. And it is connected to the operating system via VPN for the security. In the command center, the operator can get a notification in no time so that they take a proper counter actions in case of the jamming happens. Now let's take a look at the technologies we used in this system. First, the real-time spectrum monitoring software. Signal measurement is essential to detect the jamming frequency. So this has key parameters configured by the operator in advance and continue to measure and analyze the threshold level, noise level, and bandwidth, and so on in real time. So it automatically detects what frequencies are jammed. Also, the system provides a very useful and intuitive UI with a great usability for the operator analysis and operation later. The second technology to highlight is real-time direction finding. Direction finding is automatically performed in conjunction with the signal measurement, and a reliable azimuth is calculated with the instantaneous calibration functions and direction finding algorithms, such as correlative interferometer, CI, and multiple signal classification, MUSIC. In addition, this system provides a useful analysis function for the system operator, like a spectrum of the target band, direction find the result of narrow and wide band, spatial graph for the algorithm interpretation. Now take a look at how the direction finding accuracy gets improved. This is a fiber-array direction finding antenna. It detects the direction of the disturbance signal by calculating the phase difference between one reference antenna and the others. However, as you can see from the left side, the system cannot calculate the correct azimuth by using the reference antenna number 1 only, if the jamming signal exactly comes from the master direction. Okay? To address this issue, the system calculates the phase difference by using the antenna number 1 and number 3 in a row. And it automatically selects what antenna is suitable for the reference, depending on the incoming direction of the jamming signals. With this new direction finding algorithm, the accuracy has been improved by 30%. For multiple direction finding, both CI and MUSIC algorithms are available in this system, which is recommended by the ITUR. And as you can see in the table in the middle, each algorithm has its own strengths and weaknesses. In case of a multi-channel simultaneous direction finding, a CI algorithm is preferable, and MUSIC algorithm for the detecting a multi-signal in the same channel. So the system provides a variety of selections for the direction finding. The performance of this algorithm has been sufficiently verified by CRMS over the couple of years. The next one is the weak signal sensing technology for directions, called multi-channel coherence technology. If you look at the snapshot on the left side, you can easily see the spectrum captured when receiving a minus 15 dBm signal. But what about the minus 45 signals, which is around the noise level, right, it's too difficult to detect the weak signal. To get this addressed, the system synchronized the time of the collected signal from multiple receivers and sum up all of them. By doing this, the system can maintain the signal components and then remove the random noise components, which means the noise sensitivity increased itself, and then so that eventually the system can detect the weak signal well. As you can see on the right side, the incoming weak signal can clearly identified as shown in red, and the system get an accurate direction finding result. Once the system detects the direction of the incoming jamming signals, it is important to recognize where the signal comes from, right? The jamming monitoring system can talk with other monitoring systems over CRMS, such as GNSS and mobile spectrum monitoring system. So it asked the other monitoring system the direction information captured, and finally displayed the accurate location of the signal source in the digital map. And then lastly, I would like to talk about the scenario-based operation processes. Radio jamming detection and direction finding procedures has been seamlessly designed and automated, assuming that the actual jamming situation happened. So these 9 sequential execution steps ensure the precise detection and the situation propagation in 3 minutes, which enables the decision makers to take a prompt response against the jamming situation. Now, it's time to wrap it up. The more we expedite post-industrial revolution, the more we need to protect and manage the radio spectrum to support a safe, efficient, and reliable radio communication environment. For this reason, I can't emphasize enough the importance of these technologies. The automated real-time monitoring software, the direction finding improvements, and the weak signal sensing technologies bring us the capability to manage the radio spectrum efficiently and then take prompt actions. So they eventually ensure that not only is easy the operation, but also improve the work efficiency. I can say that this system and technology surely contributed to keeping the citizens' lives safe and comfortable. And this is the end of my presentation, and hope you understand what the jamming monitoring system looks like and then what kind of technologies were used in the system. Thanks so much.
Thank you very much. Please give them a warm round of applause. Thank you for the presentation. That was very informative. Once again, a sincere thank you to our moderator, Director Hwang, and the speakers of the session 3. So we're going to wrap up session 3, but before we're moving on to the session 4, we're going to take a short break for 10 minutes. So please enjoy your break. We're going to see you in 10 minutes. Please return to your seat on time. Thank you very much. All right, I hope you have enjoyed this short break. Now we'll be kicking off the session 4. In this session, we're going to talk about future technology for spectrum management. And the session will be moderated by Mr. Sang-tae Kim, CEO of Fiaa. Mr. Kim is a member of the advisory board of the Central Radio Management Service in Korea, and before he joined Fiaa, he worked at the Electronics and Telecommunications Research Institute. Without further ado, ladies and gentlemen, please welcome him with a big round of applause.
Thank you for kind introduction. Good morning, good afternoon, and good evening, everyone, at online or offline, where And it's really wonderful weather today outside in Korea, like as if to celebrate this Global Spectrum Monitoring Forum 2020. In the previous session, we had valuable information about the recent technology for spectrum measurement. So now let's move on to one step more to the future. Now, in this session, we will invite 3 speakers. The subject is focused on the maybe first one. Yes, the vision of 6G, and another topic is about sorry. Yes, okay. I remember the topic of the next session. So, in the previous session, we had a presentation about recent and current technology, like direction finding and monitoring, and neutralization technologies for threat to drone, and drone identification and jamming monitoring. So now let's move on to the first presentation of this session. I would like to invite Mr. Han-Jung Lee as a title of a trend of ITOR 6G vision. Dr. Lee is a staff engineer at the 6G research team of Samsung Electronics. Please give him a round of applause to invite.
Nice to meet you. Introduction. And this is Han-Jung Lee from Samsung Electronics, Samsung Research, and I'm a staff engineer working for 6G research and the 6G standardization. Before starting my talk, I think I have to apologize for the foreign participant that I prepared this presentation in Korean. I believe the translation team will help me a lot, so thank you. 오늘 발표드릴
Today, I would like to talk about 6G vision trends developed by ITUR. And I think my presentation would be less technical than other presentations. I will talk about the overall trends on how the 6G vision will be developed by ITUR. As you're well aware, cellular communication evolves in 10-year cycle. The first generation was analog voice, and second generation was to digital transformation, and third generation was all about mobile data services, and fourth generation was about improving the data transmission services and speed to enable video services. And fifth generation was about EMBB, URLLC, MMTC. It is about supporting these 3 use scenarios. And as a result, we can now converge mobile communications and other industries. In fact, such mobile communication technologies have evolved greatly. They are not just supporting the mobile communication, but it is now emerging as a key competition area between countries. And as these technologies become more and more important, many countries around the world are trying to achieve leadership in this technology. As you can see in this picture, not just Korea, but Japan, China, the US, Europe, and India, these countries are all trying to build leadership in 6G standardization and research and development. and they're building standardization bodies as well. And today I will talk about ITUR 6G vision development. ITUR has working party 5D, and under this working party, a sub-working group vision has been newly established, and it was established only recently, and it is now trying to complete 6G vision by 2023 June. And as the chair country of this vision subgroup, Korea is leading the development of vision, and senior researcher Choi Hyung-jin from Samsung Electronics is the chairperson of this sub-working group, and I'm also one of the major speakers in this sub-working group as well. In terms of the vision recommendation, the overall title is Framework and Overall Objectives of the Future Development of IMD. And 4G and 5G vision had similar title. And for 6G, it's going to be titled IMT Vision, Framework and Overall Objectives of Future Development of IMT for 2030 and beyond. When you look at the picture on the bottom of right-hand chart, it will give you the overall structure of the draft of vision that will be completed by June of this year. In the second chapter, it will talk about overall trends and such as the goal of 6G, and there will be frequency-related issues, and chapter 3 will talk about how the IMT has evolved until now, and 6G use scenario, and the key capabilities for those use scenarios will be discussed in chapter 5 and chapter 4. Last but not least, in chapter 6, we will talk about Wi-Fi and other cellular systems, relationship with other systems, and standardization, roadmap for 6G. So that will be discussed in chapter 6. Now, I will talk about the details of each chapter. So for the trend first, these days mobile communication are not just providing communication services, they are contributing to resolving social issues such as sustainable development goals defined by the UN. So in 2.1, there is a description in this regard, and in chapter 2.2, there will be applications, discussions, including AI, immersive communication, digital twin, and coveraging expansion, seamless coverage, sensing, and conversion between sensing and computing, and user and application trends, reliability, and sustainable. And in 2.3 and 2.4, it will look at the technical trends, the future technology reports, and technology adequacy for frequency above 100 gigahertz. Summary will be included in this chapter. Regarding frequency issues, in 6G, it will be more wide band, and this will require a lot more data traffic and transmission. 5G and 4G spectrum and all the other new spectrum and bandwidth will be included in 6G. In order to cover these services, we have to improve the efficiency of frequency, and frequency availability would be critical. So from very low frequency to ultra high frequency band, all these band resources must be utilized. In chapter 3, it will talk about the evolution of IMT. In the case of IMT 2000, it was completed in 2000, and 4G and 5G. The vision was developed first and then followed by technology development and standardization and commercialization. So That's how 4G and 5G standardization was done, and 6G will follow the suit. We are living in 2022. This is when the vision is being developed for 6G. And when vision is completed in June of next year, we will work on standardization and commercialization of 6G technologies. In the previous slide, there were three use scenarios for 5Gs mentioned: EMBB, URLLC, and MMTC. In 6G, these three use scenarios will be further expanded and evolved. And on top of that, there will be new use scenarios added. So as you can see, on top of the three use scenarios, there will be enhanced versions, and new use scenarios are being discussed now. In the left bottom chart, these are the candidate use scenarios that have been discussed so far. So there are 6 types of candidate use scenarios so far. So each use scenarios do not have a fixed title now, so they are still under discussion now. So let me briefly talk about each use scenario first. From A to C, there will be expansion of the existing use scenarios for 5G. Scenario A is about expansion of EMBB for immersive communication and hologram that requires high data transmission. And extreme communication will be expansion of URLLC, which requires low latency and high availability and high transmission reliability. Use scenario C is the expansion of MMTC. This requires multiple devices and sensors to be simultaneously services, and it will require sustainability and energy efficiency. So this scenario ABC, on top of that, there are newly added use scenarios, D, E, F. Scenario D would be the expansion of communication coverage plus air and space. And scenario E is based on AI. Through AI, communication performance and efficiency can be optimized. And on top of that, AI itself can be developed into a network for service. And use scenario F is about converging sensing with communication to effectively utilize the wireless communication system. These 6 use scenarios are now being discussed now. And this is a diagram that shows the relationship between these 6 use scenarios. But I have to mention that the number and title and diagram of these use scenarios are still under discussion. So they are likely to be updated, streamlined until June of next year. On top of these, in order to support such use scenarios, 6G would require capabilities, the core performance indicators. Until June of this year, various stakeholders have identified candidate capabilities. So about 60 capabilities have been identified initially, but compared to 8 that were proposed for 5G, 60 is just too many. So in June, there has been a meeting between stakeholders. So there has been grouping and streamlining of candidate capabilities, and that has been narrowed down to 16 candidate capabilities, and they are discussed, shown at the bottom of the slide. And some of them are conventional capabilities, and there's the AI, trustworthiness, sustainability, sensing. These are capabilities that are new to this area, and for each of these capabilities, the target values are still being defined. Compared to 5G, of course, 6G will certainly deliver much higher reliabilities and performance, but the detailed target numbers have to be determined through discussion. And the capabilities are still under discussion now, so through further discussion, they could be streamlined or expanded, or even the names of the capabilities can be changed. The picture on the right-hand chart shows, compared to IMT and 5G, it will show how the capabilities will be further evolved. So in Chapter 6, we will talk about the relationship between IMT system and other systems and offer overall standardization, roadmaps, and identify areas that requires further R&D. The roadmap will be updated further. This shows the overall 6G standardization. It can be divided into 4 steps. The future technology trends, vision, and 100 gigahertz and beyond spec technology suitability report. That would be step 1. After that, in the second step, there will be requirement of technical performance evaluation method, and format for submission will be defined. And the third stage would be proposal of candidate technologies, evaluation and validation of technologies, and fourth would be the completion of standardization. This slide shows the result of 6G Vision Workshop that took place in June of this year, and about 350 people participated in this workshop, and there were presentation made by 14 institutions. It was a very successful workshop. These were the keywords that were identified in the various presentations, and they have been mapped to the vision document. And as for the candidate of new frequency bandwidth, 7 to 24 gigahertz and sub-terahertz, these two candidates are often discussed. This is my last slide. Samsung Electronics have also published the 6G white papers in June of 2020, and in June of this year we have also published the white paper related to 6G spectrum. 6G is now going through standardization, and a lot of competition is taking place. In order to emerge as a winner in this technology, we need support and collaboration from various stakeholders. So it requires support for ultra-fast data transmission, and from low, mid, high band frequency, all these resources of frequency will be utilized to offer 6G services. Thank you very much for your attention.
Thank you for kind introduction about the trend of 6G vision. Maybe we can hope for the prosperous future with the 6G technologies and services. And the second presentation is about the spectrum-based drone identification and information management technology. This presentation, for this presentation, I would like to invite Dr. Mingyu Kang. He is a principal research of ETRI. Please give him a big hand.
Thank you for a nice introduction for me. My name is Mingyu Kang. Not Mingyu Kang, my name is Kyung Kang. Good afternoon. In this presentation, I will talk about the spectrum-based drone remote identification and information management systems. I will tell you in the following orders: outline, trends in drone remote identification, and then I will introduce drone remote identification and information management technology, which have been conducted or developed in actually South Korea and then I will conclude my talk. As drones are recently used in various fields, so many dysfunctions occur by illegal drones. For example, takeoff and landing halted by drones at Gatwick Airport, United Kingdom, 2018, you may remember. And aircraft redirected from international airports to other airports in 2020, and illegal filming using a drone at an apartment. However, previously we didn't have an effective remote identification systems or infrastructures for the countermeasure of illegal drones. Let's see the counter-drone technologies in this slide. We have three kinds of counter-drone technologies. First one is drone detection, first one, and remote identification, and physical counterattacks or neutralizations. Previously, anti-drone technologies to counter illegal drones was just only focused on the drone identification and the physical counterattacks. It's a method of detecting drones with a detection device, such as a radar or EOR cameras, and then physically removing the illegal drones with net captures, geofencing, or jammings. However, it's very difficult to effectively remove these kind of illegal activities using drone detection and physical counterattacks due to the lack of ID identification information. So there is a need for a drone identification technologies. Need to develop a small drone identification standard and appropriate candidate frequency use, wireless communication method, and test bed. And also need to database for drone identification information storage and web servers. Okay, from now on, I will introduce the domestic and foreign drone identification drone identification trends. In the United States, FAA, Federal Aviation Administration, has recently announced the final rules for remote identifications of UAV, or you may remember drones, in January last year. And the contents are as follows. All registered drones over 250 grams must be equipped with a remote ID device. And they propose three kinds of methods. And these final rules will be effective from September 16th next year. And EU, Europe, EASA, European Union Aviation Safety Agency, EASA, has also prepared the UAS access rules, specifying that drones over 250 grams, the same case as in FAA, must be equipped with a remote identification device. This final rule will be effective from January next year. And South Korea also made the related spectrum plans, as well as some plan to develop technology for identifying drone informations, unique informations. This slide shows three kinds of drone identification methods suggested in the FAA final rules. In the first messages, all remote ID capability should be built in the drone itself, and from takes off to shutdowns, drone broadcast, drone ID drone location information, velocity, timestamps, as well as control stations location informations. In the second method, remote ID broadcast modules, which is standalone modules, should be mounted, attached to drone, and limited to visual line of sight operations. In the third method, drones without remote ID can operate without broadcasting, but within only in a specifically permitted areas. That is Fiaa, FAA recognized identification area. FAA mentioned that the drone identification messages should be broadcast using unlicensed frequency bands. In accordance with 47 CFR Part 15 of FAA FCC in the United States, which are shown in the right-hand side, capture sentences and marked blue colors. And FCC also mentioned that drone identification messages should be broadcast using Wi-Fi or Bluetooth device, and remote identification is mandatory for all drones weighing over 250 grams. This slide summarizes the timeline of the FAA final rules, and as I previously mentioned, this final rule was published on January 15th last year, and the operation of both standard remote identification drones and remote identification broadcasting modules, which is standalone modules, will be effective from September next year. In Europe, EASA also made the drone identification regulations. There is a EASA access rule. Doesn't not work, I'm sorry. And EU makes it mandatory for drones over 250 grams to be equipped with an identification device. EASA also mentioned that the drone identification message they say that might be broadcast using an unlicensed wireless devices, which can be seen here. And if the required safety level is low, unlicensed frequency band can be used. This slide shows both the identification message standard and the communication standard. As shown in the upper side of the figures, you can see identification messages such as drone ID, location informations, and timestamps, etc., is the scope of the ASTM, whereas identification communication is the scope of the well-known IEEE 802.11 in the physical layer or the MAC layer, medium access control layers, Wi-Fi or Bluetooth. Okay, from now, I will briefly present the drone identification standard project, which are conducted in at-least until the end of next years. The objective of our project is to establish national responsibility systems to prevent safe accident through remote identification and management of low-altitude drones. So we are developing drone remote identification technology, as well as we are establishing an efficient management system. Okay, and we are developing 3 kinds of drone identification technologies: PRN, CSS, and Wi-Fi. These 3 technologies are developed to identify long-range and multiple drones simultaneously. Note that the PRN and Wi-Fi support one-way transmission, and the CSS, chop-based spread spectrum, supports 2-way bidirectional transmissions. To verify the transmission functionalities and performance of the drone identification information from the identification module at drone side to ground identifiers. We first defined the test items and then performed the field test. Field test results showed that the identification distance is more than 1 kilometer. 1 kilometers. This slide shows system configurations. Identification modules attached to each drones transmit identification unique informations through RF signal, respectively, and stationary type and portable type ground identifiers obtains the identification informations, and then the map-based GUI displays the obtained information. We conducted the remote identification demonstrations at the Atelier campus in South Korea. And as shown in the left-hand side figures, you can see the one ground identifiers marked with blue colors, rectangle, identifies 3 drones simultaneously. And as such, we have verified the transmission functionality and performances of the developed drone remote identification devices in real environment. And we are also developing integrated information management systems, which include DB servers and web servers. We are conducting operation verification through interworking test of integrated information management systems, as shown in the figures. We study on the candidate frequencies for drone identifications. As in the FAA or EASA, South Korea also considered some candidate considered unlicensed frequencies for drone identifications. This table summarizes some candidate unlicensed frequency bands for drone identifications. For example, 2.5 gigahertz frequency band and 5 gigahertz frequency band. This slide summarizes the actually achievement in last years. We developed the standard technologies for high reliability and low latency drone identifications. And also we are developing low power drone identification technologies in the physical layer and the MAC layers, medium access control layers for high speed. And we also are developing both the initial version of there is a version 1 of drone identification device and information management systems. Okay, in my talk, I introduced the drone remote identification information management technologies for creating safer drone use environment based on the these rules. I think that these results can be applied the following services. Anti-drone service to protect important national facilities from illegal drones. Follow-up service to prevent invasion of privacy of using illegal drones. Okay, this is the last slide of my presentations. Based on the introduced the drone remote identification technologies, we expect to establish an integrated management system to preemptively respond to safety and security threats using small drones. And also, one can reinforce the anti-drone response system with a three-step response. That is detection, identification, and neutralizations. So based on the technology, based on the foundation of drone identification messages, I expect to protect privacies and prevent invasions from illegal drones. This is, I hope that you got a benefit information from my presentations regarding the drone remote identifications. Okay, that's it. Thank you for listening, hearing my talk.
Thank you, Dr. Gyumin Gang, and sorry for a long introduction. I corrected the name to Mingyu Gang to Gyumin Gang, sorry. It was an interesting topic about the drone identification and information management technology based on drone ID signal. During this GSMF session, there was several presentations about drone detection. So it will be many discussion about during the maybe panel discussions. Now it's a final presentation. As a final presentation of session 4, Dr. Jang-seok Choi will introduce the recent radio research on the terahertz band in RRA. Dr. Jang-seok Choi is a researcher of RRA, National Radio Research Agency. Let's give him a round of warm round of applause.
Hello everyone. Actually, I'm a little confused and embarrassed because I understood that most speakers speak in Korean. So I have prepared my presentation to speak in Korean, but actually I was wrong. But anyway, I have prepared my presentation in Korea. Please understand me and please use your interpreter kit. Okay. 지금부터 최근.
So from now on, I will talk about the recent trends in radio research on terahertz band, and I'm Choi Jang-seok, researcher from RRA, National Radio Research Agency. So in my presentation, I will first talk about the overview of terahertz and what our research agency is working on. So I will first go over the concept of terahertz and explain why this is so important and what kind of research and development efforts are going on around the world, and what the public and private sectors are doing for terahertz band. First, the concept of terahertz. The frequency range is quite interesting. So terahertz, you could say it's between 100 to 10,000 gigahertz band wave, but the characteristics of terahertz has both the characteristics of radio wave and light wave. As you can see in this picture, the left is about radio wave at the gigahertz level, but the right-hand picture is from the light wave. So there is a boundary between the two, and that's what terahertz is. It has its own strength and weakness because it has both the characteristics of the longest light wave and the shortest radio wave. Because of these characteristics, terahertz has dual aspect, but it can be used entirely for one of these purposes. So there are a lot of research and development going on for terahertz, but up until now, most of the research were concentrated in light wave. And frequency characteristics, excluding the first line and the last line, there are penetration, spectroscopy, and low energy, and they are the characteristics of light wave in terahertz. So medical imaging, non-destructive inspection, and paint thickness uniformity inspection. Recently, these frequency range, because of the low latency and high speed, more and more people are paying close attention to terahertz for communication purposes. So this slide is about the research trends on terahertz from overseas. Well, I won't go into the details, but the United States, China, Europe, Japan, they are actively carrying out research on terahertz. In 2017 and 2018, these countries started research on terahertz, but they were mainly led by the government sector. And in the US, DARPA started 6G research project in 2018. DARPA is a government institution that can carry out very aggressive technology development that are difficult to be commercialized right away. So you could easily fathom that technologies or research on terahertz were considered to be a difficult challenge. But the United States, in October of 2020, they launched NextG and announced 6G roadmap. So the leadership is moving away from the government sector to the private sector. And such trends are identified in Korea and other areas as well. In Europe, these red letters show that the leadership is shifting away from the public sector to the private sector, and the US NextG and Europe 6GIA, they signed MOU in August of this year. So this is a time when international collaboration is quite critical. So let's take a look at what kind of efforts we are taking in Korea. So this left-hand chart shows the quote from white paper published by Samsung Electronics. So 6G white paper defines what kind of requirements there are, what kind of services are envisioned, and what kind of technologies need to be developed to enable such services. So this is an excerpt from the white paper. So the three main services of 6G include truly immersive XR, extended reality, and high-fidelity mobile hologram, and digital replica or digital twins. So these three main services are identified as the leading services for 6G. So they are more like application and convergence services rather than solely communication services. For 5G commercialization, there was not much convergence or fusion with other application services. So in 6G, there will be more efforts to promote convergence and fusion with other industries and other services, and there will be a lot more integrated business models. To enable such services, the key technologies, utilization of terahertz and frequency sharing study. So technologies to promote utilization of terahertz and frequency sharing study would be most important. So right-hand chart shows 6G international standard organizations. So I believe you're aware of this, so I will skip on that. ITUR 6G. So this is the frequency-related discussions that took place at ITUR. Terahertz band began to receive a lot of attention in 2019 from WRC 19. So for frequency band from 275 to 450 gigahertz. So this was when the discussions about terahertz band started in earnest. So there will be a lot more discussions and review on application services and WRC 27. This is when discussions on terahertz band frequency distribution will start. This is another picture about standardization. IEEE has identified this standardization. 802.153D task force team has published this standard. Frequency ranging from 252 to 325 gigahertz. Data rate is up to 100 gigabps and point-to-point communication. So this looks at what kind of services will be utilized. Kiosk download, infra device replacement of front haul, back haul, optical cable equipment. So terahertz band can be utilized for those 4 applications. Some of the wired services can be replaced with wireless, high bandwidth, high transmission services. So terahertz band will be used for close distance or proximity initially. So let us talk about our RRA's research on terahertz radio wave. Before I talk about this, RRA research objective is mentioned here. We are currently developing radio wave modeling. In the transmission and receipt, radio waves are used for transmission, emission, reflection, latency in multipath. So all of these characteristics can be quantified into specific numbers based on some calculation formula. So at certain points in time, we can predict the strength or propagation of radio wave. So it's a prediction technology. So this prediction technology is something that needs to be customized. As the frequency goes up, all the microwave will become more sensitive to external environment. So they will need even more high precision analysis, and it also depends whether it's indoor or outdoor, if there are any buildings or obstacles. So millimeter wave, terahertz, they will be more vulnerable to such environmental factors. So each different environment, radio wave modeling must be customized. So modeling has to be differentiated. So for millimeter wave radio, millimeter wave is defined as 30 to 300 gigahertz. RRA for 33 to 28, we have been focusing on this band. And for smart buildings and smart factories, we will look at the millimeter wave characteristics. And second would be building entry environment, and look at how the communication with short distance instead of analyzing the interference, we are currently focusing more on short distance areas, indoor wave analysis. So building entry environment, let's say the transmitter is outside the building and receiver is inside the building, and ITU also is very much interested in this kind of environment, and RRA has contributed to standardization by sharing such research results. Third would be building emission environment. Fourth is building material characteristics. When frequency was long distance, building material characteristics were not important. But in short distance, the roughness or the texture of the building material has an impact. So this is about prediction model considering building material characteristics. And this is about the development of radio analysis model of clutter in slant path. Slant path is slope or tilted environment, and this is about modeling wave in slant path. And when radio wave transmitted, it will look at how the obstacle affects this. So this is about terahertz research. I'm running out of time, so I'll be very brief. This is above 300 gigahertz. When we are looking at the equipment, the existing devices has functional limitations because it uses CW wave. It is very limited in terms of prediction. So we are using multipath or broadband signal producing equipments. So these are the equipments that we are using for basic design. And next year and the year before that, we are going to work with RF devices. These are target numbers. And then as for the building material, from 325 megahertz, this is predicting the building material impact. And this is a machine that we have set up in RRA. This will look at whether it's a glass or brick, how the radio wave characteristics change depending on the building material. And this is about attenuation. If the terahertz goes up, there will be a lot of loss created by attenuation. And as you can see on the right-hand chart, well, this shows the daily attenuation. And if there is intensive rain, as you can see, 240, 270, 300 gigahertz, we are monitoring them. And we can see the rain attenuation goes up drastically. This is the receiver and transmission installed at RRA, and it has shown that rain attenuation is very high, and we are collecting this data 365 days a year, and we have contributed that to ITUR recommendation. This is about prediction model, which is similar to millimeter wave, but the frequency is higher. And it also looks at indoor environment, and we came up with this system environment. So if you go above 400 gigahertz, there will be a lot of loss. And when it is duplicated with shared frequency, the loss will go up dramatically. So these are the critical factors in terahertz system, and we have developed a lab system for measuring this. So we have put in some gas to look at the impact. This is the ITU application, and this is about radio wave modeling from 275 to 450 gigahertz. This shows terahertz antenna array and measurement devices. They are not available in the market because they are so expensive. So it's quite challenging to set up this kind of system for operation. But in spite of that, we will continue to work on setting up the antenna and fine shaking simulation system. We have actually set up the system for measurement. This is the conclusion. 6G is right around the corner. So in 2030, 2029, 6G will be commercialized. And now the private industry is joining these efforts to research 6G. Samsung Electronics, SK, and other private sector companies will actively carry out research. And our future plan is about developing radio wave model based on application services, such as EUM 5G and V2X communication system will be connected, and we will carry out further research in this area.
Give a big hand, everyone. I do appreciate for the presentation, and I would like to express a special thanks to our moderator, Mr. Kim. Thank you very much. Next, we'll have a special session, Spectrum Management of Participating Countries. For today's special session, there will be a presentation by 3 speakers from Bangladesh Telecommunication Regulatory Commission and Communications Regulatory Authority of State of Qatar, National Authorities for Management and Regulation and Communication of Romania. And the special session will be moderated by Mr. Chu Nam Lee, team leader of Korea Radio Promotion Association. And Mr. Lee currently serves as the head of the International Cooperation Team, and also he is in charge of the International Development Cooperation. Ladies and gentlemen, please welcome him with a big round of applause.
Thank you. Nice to meet you. I'm Junam Lee from Korea Radio Promotion Association. I'm a moderator of today's special session. As I mentioned yesterday, knowing each other is very important because spectrum across the border easily. So to prevent the unwanted interference, we have to know neighboring countries' spectrum management status. In this point, we have 3 distinguished speakers today. The first special speaker is Mr. Awar Uddin Ahmed. He's the Director of Spectrum Division from Bangladesh Telecommunication Regulatory Commission. He's going to tell us the state of spectrum management and monitoring in People's Republic of Bangladesh. He's online right now. Please welcome Mr. Awar Uddin Ahmed.
Hello. Good morning, noon, and evening to all the distinguished guests and the forum members. Am I audible, please? However, I welcome you all. I welcome you all to the presentation on a spectrum management policy of Bangladesh. At the very beginning of my presentation, I would like to convey my heartfelt thanks and gratitude for the warm hospitality of the concerned authorities of the Republic of Korea. At the same time, I feel truly honored for inviting me and also giving me this unique opportunity to present in this forum. Now, in the past, just to now for the introduction. In the past, the availability of spectrum was a minor issue for any nation, as there was ample of spectrum access to meet its needs. However, today's new technologies, especially the wireless technologies worldwide, have made maintaining the spectrum allocations difficult. New exciting wireless communication products are creating a large demand for spectrum. And the wireless subscriber services are growing rapidly worldwide. Emerging countries, in an effort to modernize, are choosing to deploy the wireless infrastructure in lieu of the previously wired infrastructure, since it costs less. So all of these factors have really made a more competitive environment for the spectrum access. So with this little bit of introduction, I'm switching. Sorry. Okay, I'm switching to the aim of my presentation is that to apprise you about the spectrum management policy of Bangladesh. The scope, as you can see, is flashed on the screen. My presentation is going to unfold in the following sequence. Firstly, I will try to give a brief description of the organization and the managing instruments of spectrum in our country, followed by the planning and coordination of frequency uses, assignment of spectrum, and finally monitoring and resolving the RF interferences issues. And I'll be concluding with a small little conclusion as well. So with that, first, the organization mandated for the spectrum management is that Bangladesh Telecommunication Regulatory Commission is the responsible organization for the spectrum management with a vision to facilitate connecting the unconnected through quality telecommunication services at an affordable price by introducing the new technologies. And these are the managing instruments we have for managing the spectrum in our country. Firstly, our spectrum is managed in Bangladesh according to the Article 55 of Bangladesh Telecommunication Act of 2001, which was later on amended in 2010. And followed by, we have a standing spectrum management committee, which recommends regarding the spectrum assignment to the commission. And we have a national frequency allocation plan, which was prepared through the international experts consultancy based on radio regulation published by the ITUR. Now the spectrum management, spectrum division of Bangladesh Telecommunication Regulatory Commission carries out the essential activities needed to ensure efficient and effective allocation and use of the spectrum for radio services. The tasks are categorized as below. Firstly, the planning and coordinating the frequency uses, followed by assigning and managing the spectrum itself, and finally, last but not the least, is very important, which one is the monitoring and resolving the RF interferences issues. Now let's switch to the first thing. How do we plan and coordinate the frequency uses? For this, our baseline is that with an aim, we have a national frequency allocation plan. So with an aim to achieve the efficient use of spectrum, BTRC had published a national frequency allocation plan. In short, we call it NFAP in 2010, which was updated in 2018. The NFP is consistent with the radio regulations of the ITU. And this NFAP is updated in a timely manner to reflect changes in the radio regulations. And this is currently our spectrum assignment scenario of IMT for IMTs. As you can see, it's a big slide with a lot of information, really. But if we start from this side, it was in 1 gig. First generation, we started back in 1993, and followed by in 1996. And then in 2003 and 4, we introduced GSM 1800 megahertz band, and we allotted 40 megahertz to our 4 of our major operators. This GP, Robi, BL, and Teletalk is our mobile network operators in our country. And then later on, in 2005, we again allotted 15 megahertz from GSM band to Airtel, another operator. And subsequently, as you can see, we have conducted our last allocation in this year, 2022, the last of March of this year, where you can see the allotment. We have given 70 megahertz from 2300 band, 2.3 gigahertz band, and 120 megahertz from 2.6 gigahertz band to the MNOs. And their usual auction price was settled down at $6.5 million per megahertz. And the bottom line of this slide is reflecting, as you can see, earlier we used to give it from 1993 to 2004. Our policy was to give or assign the spectrum to the IMT band to the operators free of cost. Later on, from 2005 up to 2011, we allocated or assigned it to administrative process. And finally, as in today, back from 2013 and onwards, we are following the open auction process for assigning this spectrum to the mobile MNOs. This slide reflects the spectrum bands for the fixed microwave links. As you can see, it's the BG slide. I would like to draw your attention to the right-handmost column that all these are in compliance with the ITU recommendation. This slide reflects the spectrum bands for our only satellite. We have a Bangabandhu satellite, BDSat-1. So these are the various frequency we have earmarked for this uplink and downlink satellite communications in our country. Now, as you can see, this is the spectrum bands for broadcasting, aeronautical, and maritime services. Just these are also, as you can see, these all are in compliance with ITU-R regulations. And for broadcasting, we have from 87 to 108 megahertz and these frequency ranges in various slots. For UHF TV, we're using 522 to 617 megahertz. For maritimes, we have our HF bands, RANs, and VHF bands as well. And for aeronautical, also we have HF and VHF bands. Now, regarding the levels of planning and coordination for this frequency allocation, we do usually it in three levels of coordination. Firstly, at international level, we are the signatory of ITU. And as a regional member, we are the member of APT, which stands basically Asia Pacific Telecommunity. And finally, we have a sub-regional community for this spectrum, that is South Asian Telecommunication Regulatory Committee. So we are a member of all these three organizations, and we do coordinate and plan our frequency accordingly in all these three tiers. Now, next switch to our next one, that is assigning and managing the spectrum. So this slide shows the flowchart of how do we really assign the spectrum to the users. The procedure, first of all, the applications from the stakeholders are being received, which is being examined by and scrutinized by the Spectrum Division. Then it is being sent to the Spectrum Management Committee. And finally, with the Spectrum Management Committee recommendation, the assignment of spectrum, either auction or from administrative process, and it goes to for the approval of Commission. Once it is being approved in the Commission, then the fixation of price is being done through the auction or sometime administrative process. The payment of fees and charges are being made, and finally the issuance of assignment letter is being given to the user end for the spectrum. That is how, in short, how do we really assign our spectrum to the user end. Now we have a standard formula for the annual spectrum charge. So where we have a standard spectrum tariff unit, which we revise time to time, and we have some other constant factors of our area factor and some all the factors. So with all this is the annual spectrum charges formula in our country we follow. Now finally, let's the monitoring and the resolving of RF interference issue. So I would just like to mention that this picture reflects the Bangladesh and the Republic of Korea have very strong diplomatic relation. We attach the great importance of our relation with the Republic of Korea, our tested and trusted friend and an important development partner. We have been enjoying this excellent bilateral relations since our independence, and we are always thankful to the Korean government for the persistent support in our ICT sector. As a part of such and support, this Korean spectrum monitoring system, as you can see on the screen, this system was given by the ONPOM, the Korean monitoring system company, ONPOM, to the Bangladesh back in 2020. And since then we are using it reliably, and we found it to be very effective and very sophisticated, a modern one. Because we are in parallel, we are using some other system as well. So we found it very effective and dynamic. So you found this is the monitoring system presently we have. We have three types of monitoring system. As you can find, this is the fixed monitoring system. We have mobile monitoring system, this vehicular version, and also the portable monitoring station, PMS. You can see this picture. These two guys, they are working with this handheld monitoring system. This is also given by this ONPOM. We're currently using this. And scanning and direction finding capabilities of the system is usually from 20 to 300 megahertz, and the receiving sensitivity is minus 120 dBm. And using the handheld spectrum analyzer, the scanning capabilities is rise from 9 kilohertz to 26.5 gigahertz. And rightly, this slide, as you can see, countrywide fixed monitoring stations. We have as total 6, including 1 in the capital Dhaka, and 5 other are located in different divisional cities. And we have a future development plan for this enhancement of this monitoring system. As a part of those, we are actively thinking on the adoption of new technology for spectrum monitoring purpose to enhance the monitoring capacity from 3 gigahertz to 8 gigahertz with direction finding capabilities. And we have also the plan to establish more fixed monitoring stations in the potential areas around the country. And the development is in progress with the latest ASMS software system in Bangladesh. And truly what we need is the capacity building of the personnel responsible for spectrum monitoring. So we are actively thinking on this. So with that, I have come to the conclusion of my presentation. So to conclude, we may say that radio spectrum is required for the use of a wide variety of radio communication services, which in turn are subject to a diverse range of legislative controls and policy intentions. So that was all about my today's presentation. And finally, I would like to seek the opportunity to thank the government of Republic of Korea 1,000,000 times over for your kindness and generosity. It has touched my heart during my stay in your country. It means so much to me. So please do accept my sincere thanks. Thank you very much for your patient hearing. Thank you all.
Okay, thank you so much. Very impressive presentation. This year, the 2022, there are 2 very important big global events. The first one is Global Spectrum Management Forum, and another one is the FIFA World Cup held in Qatar. Such a huge event like World Cup, there must be an extremely high traffic caused by mobile broadcasting, drones, and so on. In addition, there are so many demand for spectrum too. Mr. Mohammed Ibrahim Ahmed Sadek, a department director of Spectrum Management of Communication Regulatory Authority in Qatar, is going to share their preparation for FIFA World Cup. I can't wait for the Qatar World Cup and Mr. Sadek's presentation too. Please welcome Mr. Sadek.
Excellencies, distinguished colleagues, good morning, good afternoon, and good evening to everyone. My name is Mohammed Sadiq. I am Director of Spectrum Management Department in CRA Qatar. I'm very delighted to be part of this year's forum and would like to express my gratitude to the CRMS for their kindness and hospitality received from the day we arrived to Seoul. My colleague, Mr. Kush Abraham, and I will be presenting our preparation for the FIFA World Cup, which will be held in Qatar, I think, from the FIFA website in 73 days, 23 hours, 19 minutes. And our presentation will be from a spectrum monitoring perspective. We hope by end of this presentation, everyone will appreciate the challenges we have in spectrum management with respect to major and special events. So before going on the technical details of my presentation, I would like to give some insights about Qatar and the ICT sector. So Qatar is a Muslim Arab state located on the west coast of the Arabian Gulf. Doha is the capital Doha is a capital, a coastal city with the picturesque Corniche on the eastern side, which is home to the most of the country inhabitants. Qatar blends the nobility of the past with the modernity of the present by preserving cultural heritage while remaining open to modernity, prosperity, and welfare. The state of Qatar is the largest exporter of the liquefied natural gas in the world. It is moving strongly towards total transformation, towards a reliance on clean energy and reducing carbon emission by adopting the highest environmental standards in the industry. Arabic is the official language of the country. English is commonly used. Population of Qatar is 2.9 millions. 95% of population reside in 35% of Qatar landmass. Telecom ICT sector, Qatar has achieved significant progress in digital transformation by expanding its ICT industry and boosting human resource capacity. The mobile penetration of 145%, fiber connectivity to households of almost 100%. Revenue of the telecommunication service about 10 billion riyals, and the contribution from the ICT sector to the economy of 1.7% of the GDP. 5G in terms of coverage population, we can say that 98% of Qatar is covered by 5G, and each operator has 1,000 megahertz bandwidth for the 5G, 200 in the C-band, and as the two carriers, and two other carriers of 400 megahertz in the millimeter wave band. CRA is the Communication Regulatory Authority, regulate four sectors: communication and information technology sector, postal service, and access to digital media. CRA protect consumer rights, ensure competition, manage the resolution of disputes, and manage the scarce resources, including the radio frequency spectrum and satellite orbital resources. First regulatory body was established in 2005 under the ICT Qatar, the Supreme Council of Information and Communication Technology. And in 2014, there was an Amiri decree to establish the CRA. For our preparation for the FIFA World Cup, CRA developed and published different regulatory instruments. I'll highlight some main elements, which are the CRA strategy for the 2020-2024, Spectrum Outlook 2022, and the Spectrum Plan for FIFA World Cup 2022. So in our strategy, we are aiming to innovate and growing the IT sector, competitive and innovation in telecommunication sector, strengthen regulatory regime to support access to digital media and sustainable postal sector. The outlook was published in 2020 for a period of 3 years. It gives insight with the CRA approach and plan activities for the next years, and cover the mobile service, satellite service, broadcasting service, and the BMSE, the program making and special event application. As one of the obligation to the FIFA, CRA is classified as a spectrum management service provider, and there was a commitment of, or guarantee from the government to issue the spectrum plan for the FIFA World Cup 2 years before the event. So it was published in 21st of November 2020 and updated this year with some important information. The spectrum plan include detailed spectrum plan for the FIFA World Cup, also the procedure and plans for authorization and licensing, activities, schedule, and protocols. I think for hosting this big event, it is first of its kind to have all stadiums close together. And this is a challenge for spectrum management in terms of management and monitoring. We have 8 stadiums, official 8 stadiums for the FIFA World Cup, and training pitches, and all contained within 235 square meters. The shortest distance between 2 venues is 5.5 kilometers, and the longest is 55 kilometers. Fans can watch 2 matches a day, and if you go from the stadium in south to the stadium in the north, it will take you in 2.5 hours to reach there. So what we did towards this special events, strategic project were approved by the government to be done by the CRA. The first one is the automated frequency management system. This system is already exists in CRA, but there was a requirement from FIFA to upgrade the existing system to include new modules for program making and special events. So we did this upgrade, and the system is available now to deal with all application of spectrum requirement for different stakeholders. In terms of automated spectrum monitoring system, we did augmentation of the nationwide SMS to enhance the monitoring coverage to all venues during the FIFA World Cup with 3 hybrid station, 13 TDOA sensors, 2 transportable TDOA sensors, and 2 mobile monitoring stations. We have a new big project for this FIFA World Cup, which is the Space Radio Monitoring Center, to monitor the GSO, NGSO satellite in visible arc, identify and geolocate transmitters, monitor, geolocate, and track mobile VSAT terminals. We have also a drone detection system to detect, classify, and locate unauthorized radio controller drones and their operators within a shield area during high-profile events. We have also smart analytic and remote probes, remote quality of service, measurement of mobile networks in all stadiums and major venues. As well, mobile KPI monitoring dashboard remotely monitor the key performance indicators of both service provider in near real time on a centralized dashboard. Now we'll give the setup of our monitoring network. Mr. Kushi will present this, and I'll back.
Thank you, sir. Let me take you through the process that we went through while planning our spectrum monitoring network for this event. So our history for the spectrum monitoring network started in 2001. We had a couple of fixed monitoring stations and mobile monitoring stations, both aged over, and by 2009 we plan to have a new system which would take care of the whole nationwide spectrum monitoring. So as phase 1, we covered with 4 fixed stations and 2 TDOA sensors, as well as 2 mobile monitoring stations, all capable of monitoring up to 8.5 gigahertz. For the World Cup project, for the 2016 onwards, we plan to enhance it, and the following slides will give an insight to how we did it. So initially, we had 4 sites, as I mentioned in the previous slide. We had 4 sites in the northeast and south of Qatar as phase 1 of our nationwide project. But you see that the entire area that is showed here is the core area where the FIFA World Cup is taking place. All activities will be oriented in these 2 areas, the stadiums as well as the fan zones as well as training stations. So the colorful diagram you see is actually the heat map of direction finding and geolocation with the existing system. As you see, there is no we couldn't achieve the geolocation from a centralized area with the existing sites. So what we considered during this time is that we wanted to target the area, the 8 stadiums, the training centers, the non-competition venues, and hotel and fan zones, which are focused in the polygon that you have seen. And we focused on transmitters, which will be at 1.5 meters height, and the category 1 transmitters, I mean. And the primary objective was to have remote monitoring with a miss of less than 200 meters. So for this process, we planned a network in 2 stages, that we will have a primary network and underneath over a secondary network. So the primary network was intended so that we have an angle, the AOI coverage primarily over all these areas, and so that even if we miss the geolocation, we could do it by the hybrid mobile monitoring station we have. And the secondary network was a TDO-only network, which will overlay the primary network. So if you can see that with the primary network, we were we chose we chose hybrid networks, hybrid sites, which is both angle of arrival as well as TDOA sites, in three new stations, so that we can cover the area with our FMS fixed monitoring stations as well as our mobile monitoring stations. But you see, still we have we still have a miss of in the core area, a miss of more than 2.2 kilometers. So our intention with the second layer, with the next layer, was to have a clean 200-meter 200-meter resolution for geolocation. So with these three hybrid stations, we were able to provide an angle of blanket AOA coverage in the entire area. So for the next layer of network, we did a couple of iterations where we tried 30 kilometers, 15 kilometers, and when our target of 200 meters were achieved with a nodes at 7.5 meter. So we planned for network sites at 7.5 meters, taking into other considerations as mentioned in the ITU handbook. So here, after the TDOA layers were put, we got a better TDOA miss out accuracy, and the areas that we have highlighted were able to achieve accuracies of about 100 meters. So some of the simulation parameters that we took was was the propagation model, and the accuracy of the AOA was 2-degree RMS, as well as TDOA accuracy was about 200 nanoseconds. So if you see the color representation, the purple color will give you a resolution of about 50 to 100 meters, whereas the other, the green, the red is the worst with about beyond 1,000 meters. So this seems to be an optimum for us to monitor and geolocate the transmitters within from our central monitoring center with an accuracy with a level of less than 100 meters. But obviously, everything that is planned doesn't work as until it can be implemented properly. So due to various factors, we did not get the correct locations, as in all planning activities or implementation stages. We have issues. We have managed to get at most of the places the site we have intended. But as you see, there is the red and the green dots are the one that is actually implemented, and the white dots are the ones that we planned. So there was a miss. There was some holes. So what we plan to do is to cover these holes by means of transportable TDOA sensors, as well as use our mobile monitoring stations, as well as when we go into for the stadiums and for the venues, we will use our handheld spectrum analyzers and automatic direction finding systems. So what do we do with these sites after the World Cup is over? This is our intention. We plan to prioritize our primary network of Qatar and move the sites from within Doha to the rest of the country, so that we'll have DF and geolocation capabilities for spillover monitoring from our neighboring nations, as well as geolocate within our urban areas. Multiple sites will be put in our urban areas. So another, as Mr. Sadiq said, we are also moving for renewable power in the coming years. So over to you.
Thank you, Koshi. And now the Space Radio Monitoring Center in Qatar. This is the big project we have now. And this is the perspective of our new project. We are going to geolocate and monitor in GSOO and NGSO. And we will be able to track and geolocate VSAT terminals. This is maybe the first one of the first countries in the world to get this feature in space radio monitoring. And also we will be able to do tactical mobile monitoring for space radio, as well as last mile interference hunter by RF monitoring drone. And this center will be launched in November this year. From last year, when we start thinking of having the new space radio monitoring center, we also thought to have some agreement and MOUs with some administration. So there was a memorandum of understanding signed with the TRA Oman in 2019. And there was a comprehensive discussion with the CRMS of Korea. And we are expecting to sign MOU in October next month, as well as Anatel Brazil. The plan is to sign another MOU with Anatel in October during the BB 2020. So CRA is a really active member of ITU and Regional Office in Spectrum Management. And we collaborate with different administration and looking forward to sign maybe more agreements with other administrations. And we are sure that this will be for mutual benefits of administration, especially when you have a system that needs help from other administration from different locations of the world. So with this, I think I can conclude my presentation. This is our preparation for the FIFA World Cup, and we are looking forward for a successful event for us, and maybe to see all of you in Qatar, and we will welcome everyone in Qatar to enjoy this special events in November and December. Thank you very much.
Thank you for your presentation, and I'm absolutely sure that the FIFA World Cup Qatar will be the most successful World Cup ever. Okay, last but not least, we have one last distinguished speaker all the way from Romania. Mr. Octavian Nicolae Lufu is online. He is the head of Aeronautical, Maritime, Satellite, and Amateur Unit from National Authority for Management and Regulation in Communication of Romania. Please welcome with a big applause, Mr. Octavian Nicolae Lufu.
Thank you very much for your presentation. I'm very honored to participate to this forum hosted by the Republic of Korea. And of course, it's for the first time when we as Romanian administration has this presentation in order to make known our desire to build something maybe old for other countries, but for us is very new. That means a satellite infrastructure. I'm the head of the Satellite, Aeronautical, Maritime, and Amateur Unit from the National Regulatory Authority for Communications of Romania, with the name ANCOM. The presentation is entitled Coordination and Monitoring of Geostationary Orbital Position by the Romanian administration, a very ambitious project. This presentation will follow 5 very important topics. Therefore, in order to establish a Romanian national satellite system, we have to follow these lines of action. First of all, there is a need for defining the strategy for developing a national satellite system. This is obvious. Next, there is the identification and coordination of orbital positions, both planned and unplanned, according to ITU rules. Also, it will be necessary to develop a national satellite radio monitoring system. Next, we will develop, and we are developing practically, a computer-aided technical software for satellite coordination and management. And of course, there is a need for ensuring continuous innovation according to the state-of-the-art technologies. We shall move further to the strategy part. First of all, this is Romania, a beautiful country situated in the southeastern part of Europe. You can see from this geographical map that we have various heights, starting from the sea level to mountains, Carpathian Mountains, that are going around 2,500 meters. Therefore, from a telecommunication point of view, this is very challenging in choosing the right options in how to make this coverage. Of course, Romania is situated, as I said, in the southeastern part of Romania and is a part of the European Union. We are close to we are in fact at the one of the Black Sea country, and we are very close to different events in the area. Now, the Romanian National Satellite System represents an ambitious project intended to offer multiple benefits for the country, being regarded as useful in numerous areas of activity. Therefore, this project will provide a catalyst for economic development. Next, it will ensure sovereignty in the space domain. This is a very important topic now. Also, this project will promote a long-term efficiency, economically and socially. Also, this project will be an occasion to invest in a national strategic asset. And of course, this project will increase national cybersecurity. The challenges might become opportunities in gaining access to the orbital positions by developing national competence in the field of the satellite international coordination and monitoring. We are starting from the greenfield, from the scratch, as can be so. Next, we shall identify possible partners with other administrations sharing common interests and goals. And this is one of the purposes why we are speaking on this forum. Also, we shall develop a national satellite monitoring system in the intended radio bands. Also, we need to understand and measure the real occupancy of different radio bands. And also, we have to take preemptive steps based on realistic estimations offered by the surveillance of possible interferences. Next, we shall move to the coordination part. Till now, our administration submitted to BRITU several parts of this project. As it can be seen from this slide, there are 3 unplanned requests with the name Milsatcom 1, 2, and 3. Also, there is a request for changing an orbital position according to Appendix 30 and 30A. And also, we activated or changed the status of our allotment to assignment for the Appendix 30B national satellite reserve, country reserve. Regarding the coverage from the point of view of Appendix 30B national plan, this is the C-band, very generous. You can see that this coverage also is making possible communication not only in Romania, but also in the neighborhood. This is very important. The intended bands for this project are according to Appendix 30B. These are, as mentioned on this slide, and will be 300 megahertz continuous duplex band. Of course, polarization will split or maybe will double the capacity, splitting between feeder link and user link. The service area will be Romanian territory, and with agreement on other countries, we shall extend in the neighborhood, and also we shall include our territorial waters from Black Sea. The diameters of the user link stations we want to reduce from what is a plan, and this is a big challenge. Next is the coverage for the KU bands according to Appendix 30B plan, and the allotment for Romania. It's a little elliptical, but also very generous around our country. This plan comprises different bands with an amount of 500 megahertz continuous duplex band. Therefore, by making polarization discrimination, we shall use one polarization for feeder links, the other for user links. The service area, as mentioned before, will be Romanian territory and surrounding area. Also, a big challenge will be to change the diameters of the dishes for user links from 2.7 meters, that is in the plan, to 1.2 meters. This is a very ambitious objective. Regarding another resource is for Romania, we can find in Appendix 30 and 30A. It's a BSS coverage in KU band, a little more tilted because it's put on the 50 degrees east orbital position. Also here we have a possible application, and we shall do it according to the plan if this will be possible. We don't have a plan now, but it will be considered in the future. Also, we consider to change our resources from the BSS plan to another position in the 23.4 degrees west. This is the usage and will be according to the plan. Next will be the MILSATCOM or unplanned satellite networks, very complex in a lot of bands intended, but basically our focus will be on X band and K band and V band, and all the other details can be seen from this slide. The similar will be in other orbital position that is candidate for this plan in 33.5 degrees east, the same usage, and also from the 26.5 degrees longitude for another option. Of course, this project is not in the state of defining a quiet orbital position. We are studying and we shall do the best option. Also, the problem with coordination, there are many challenges because of the high degree of congestion, of different interference that are not realistic estimated. Also, they are challenging because many satellites are in coordination phase and are already theoretically put there in the ITU BREFIC publication. It's very difficult to assess the real occupancy without having a monitoring system, and also we don't know which will be the interference upon our networks when we will go to the phase of implementation. Next, we go to the monitoring part. Regarding the monitoring part, we want to develop a national radio satellite monitoring system according to ITU monitoring handbook. We are in the process of finding the best sites for placing transportable sensors of the satellite monitoring system, and we shall allow the use the various terrain options of Romania, ranging from, as I said, 0 meters above sea level to 2,500 meters above sea level. We want to have a good estimation in various test points of the coverage of Romania, and we want to conclude memorandum of understanding with ITU and other interested administration. Here is a sketch of possible implementation and possible placement of the transportable sensor for this monitoring system. The main interest for us will be in the geostationary part as much as possible from placing in Romania. And also the intended bands for monitoring will be X band, KU band, K band, and with future bands as V-band and G-band as the technology will evolve. Of course, we shall try to do it in the best place to put these sensors and to have a global coverage of the country. Regarding this developing of the Radio National Satellite Monitoring System, we have first to determine the feasible places according to ITU Radio Monitoring Handbook. We shall estimate the best sites for placing the first sensors. We shall conduct feasible studies in the best sites, and we shall purchase transportable sensors from the best developers and manufacturers on such system. Also, we shall try to have or to develop mobile sensors and adding other sites. Next, we go to what is called the software for computer-aided technique, according to ITU nickname, for satellite coordination and management, a very important software that we have to develop, as I said, from the scratch. The requirements for a computer-aided technique for satellite coordination and management will allow the satellite coordination based on bilateral agreements between administrations. This software will offer a good optimization of the coordination process, and also it will be shared with other administration in order to have a common view and a better usage of the allocated band for satellite communications. Now, regarding a possible harmonized method, this can be found in the section B3 from part B of the ITU rules of procedures, a very practical method that is always mentioned in the World Radio seminars of ITU. This tool will be matched, of course, with the space spectrum monitoring software. The basic principle of principles of the computer-aided technique, as mentioned before, will be based on the foundation of the program will be based on the ITU Shape DBM and GMAPIS 32 software libraries. These are free libraries put at the disposition of any interested administration by ITU and can be found in any BAR IFIX Space Services edition. The programming language of choice will be C# from .NET package, this compiler being implicitly available on any Windows workstation. This is a very important and very practical remark. The input data is provided by the databases included in the BRI Fixed Space Services publication, basically in the MDB files developed by SpaceCap and GIMS software. Other input data will come from monitoring systems, and the output will be provided in MDB files that will be exchanged with other administrations. The programming of this computer-aided technique will be as follows. This software will be defined as a script to be run on any Windows computer using the source code written in C# as a common ground in an open source manner that will prevent security issues. The behavior of the program will be defined through an initialization file that will direct the actions to be performed in a Linux-Unix fashion. The output files will have meaningful names according to the satellite networks compared in a paired approach, existing versus incoming networks. And the output format will correspond to the ITU rules of procedures, part B, section B3. Next, it's about the cooperation in the field of satellite coordination and management. Of course, our administration is open for international cooperation with mutual benefits. We have the plan to install satellite radio monitoring stations in Romania in order to sustain the satellite coordination and management. The method described in ITU Rules of Procedures B3 section is considered as a strong basis for a software package that will integrate BRI IFIC databases and the data provided by Spectrum Monitoring System. This software is to be developed in an open source manner and will evolve according to the experience gathered in the satellite coordination and monitoring domains. Here is a look of the SpaceCap, and with an input put here from Minsatcom-1 network that belongs to, that was submitted by Romania. This was put as an existing test network. It's only a simulation, and we consider an incoming network, Minsatcom-2 network, in order to perform a simulation and running of this program. Here is the input or maybe the configuration file that is in a Unix style, very easily to be edited with any notepad. And here is the output data in a very intelligible and practical way. The details can be provided after this meeting, of course, and in other occasions. Next, we move to the part of innovation, continuous innovation. Innovation is a key point regarding the development of the Romanian National Satellite Project. Innovation is driven by the advance of new space technology, like software-defined satellites, beamforming satellites, IoT, with high throughput, NGSO constellations, cognitive communications, a lot of technologies that offer new possibilities. Innovation driven by advancing toward higher frequency bands. For instance, there is a tendency to move from K bands to V, G bands, and X to W and millimetric bands, as was mentioned even on this forum. The innovation also is driven by the coming of other communication media, optical and quantum, and we have to take into account this evolution. The innovation is driven by new ground station technologies like space diversity, with multiple teleports or gateways, and with synthetic apertures. Also, the innovation is driven by hybrid space architectures with multiple bands and including different types of orbital positions, geostationary, NGSO in the LEO, MEO, or HEO type of orbits, and so on. Innovation is mandatory for incorporating in real time the latest major technologies for our project. Design and redesign the structure and the elements of this project is very important. We have to choose the major technologies and advance with new technologies, not allowing obsolete ones to impede the evolution of the system. We don't want to purchase or to develop something that is not state-of-the-art. We have to enter into the research and test area of new technologies that are promising due to the main vector of development, and therefore we want Romania to be a test bed for new technologies and new approaches in the satellite domain. And also we have to synchronize all these aspects with the user demands characterized by higher data bandwidths, low latency, smaller antennas, mobile and portable high usage. This is the main focus because we design a satellite network for the for the nowadays technologies, and the user dictate at least this kind of technology that will be used. Also, we have to use the best from the geography of the country for placing the best teleports in the best places and to define smaller beam spots according to the user distribution profile in real time. And now we are moving from geography to demography, because in the beginning, the geography was the main input in developing a telecom plan. Now we are moving to demography, and 5G, 6G, and other technologies basically are moving from geography to demography. This is a very important tendency. Here is a sketch, for instance, of shape beams with different, basically these are the counties of Romania, covering these counties, because each county has each demography and its specifics or has specifics. We can have, for instance, the pink packages with specific frequency band and polarization, green packages with other specific bands and polarization, blue packages, red packages, and so on, and yellow packages. And on this way, we shall try to find the real innovation that will allow Romania to be covered not only geographically, but also demographically. This is very important. Thank you for your attention, and we are open to any kind of discussion in this occasion or in another occasion. And also, I'm very thankful to the Korean administration for hosting this wonderful event. Thank you very much.
Thank you very much. Please give them a round of applause. That was a presentation of our speakers from 3 different countries. Thank you very much for taking the time to speak to us today. Now we're going to conclude the special session, and we're going to take a 5-minute break. Refreshments are prepared in the lobby, so please enjoy, and I'll see you in 5 minutes. Thank you. All right, ladies and gentlemen, the panel discussion will begin shortly, so all the participants in the lobby, please come inside the hall and take your seat. The panel discussion will begin momentarily. Thank you. So shall we begin? Now we'll have a second-day panel discussion, and I would like to invite Mr. Chong-Hwan Hwang, Director of Electronics and Telecommunications Research Institute, as a moderator of panel discussion. Ladies and gentlemen, please welcome Mr. Hwang with your warm round of applause.
Hey, yeah, thank you for nice introduction. So, all the presenters, could you come over here and sit down, please? Now we have behind the schedule by about 30 minutes already. So actually I made train reservation before coming here, but I have to delay my train because I think this panel discussion will not be over within 25 minutes. It will take longer, so I would like to suggest other people who made train reservation to delay your reservation in advance. Okay. We are very close to our GSMF 2022 forum. So before starting our panel discussion, I would like to check our online guest. So, online guest, do you hear us from there?
Yes, you are very loud and clear to me.
Okay, that's okay. So that's it. And I would like to wrap up today's presentation very quickly. So. In my opinion, we could summarize today's presentation with just one word, that is next. So next is a very appropriate word to summarize this today's presentation. So first of all, we talked about next to spectrum monitoring system. So LIG, Nexon, and OMPUM, they presented several key technologies for next generation spectrum monitoring. And also we talked about next to spectrum. So Samsung and LRA, they introduced 6G vision, and 6G channel model. So another next item is, I think it would be next step after drone industrialization. So as you know, we are using drones more and more. So anti-drone technology are becoming important more and more. So we have a presentation by Fiaa at Samsung Industries, and so they talked about preemptive techniques to prevent drone attack, and also they presented reactive action, that is detection of illegal drones. So that is my short summary of today's presentation. And like yesterday, I would like to open this panel discussion to the floor. So if you have any question, please raise your hand and introduce yourself very quickly and ask a question. Then our presenter in front and online will answer your question. So, yeah, please.
Thank you, Mr. Chair. First of all, I'm Ahmed Kormed from the Egyptian.
I'm sorry, could you?
I'm Ahmed Kormed
yep.
from the NTRA, National Telecommunication Regulatory Authority of Egypt. I'm senior engineer in the Spectrum Management Department. First of all, I would like to thank GSMF for this kind invitation. I'm very honorable to attend this, and thank CRMS for the generous and very kind hospitality and organization for this forum. My first question was about the monitoring systems for terrestrial mobile systems. I saw that the direction finding was until the 7.5 gigahertz, and no systems was mentioned for the millimeter wave, as we all know that we have 5G in the millimeter wave. So what about the status of the direction finding in this frequency band? My second question was about, I need to know more information about the regulatory framework for drones in Korea. Do it require license or not? Or it is allowed for users or just for organizations? I didn't have any information about the current regulatory framework for drones in Korea. I just need to take this experience. Thank you.
Okay, let me summarize your question. So your first question is about terrestrial mobile system. So you ask about direction finding at 7.5 gigahertz and also at millimeter wave. So your question above, yeah, above millimeter wave, you mean? Okay, so that is your first question. And second question is, do Korea have already have license and system for drone? You mean I think you mean a kind of certification procedure. So you asked Korea already have such procedure or regulation related. My understanding is right? Okay. So I think the first question can be answered by LIG next one, and OMPM. Is that right? So who's gonna answer this question? Oh, you can speak in Korean if you want, because we have translator. So it's up to you which language you wanted to use. Yeah. Mr. Yoon, please. So his question is about direction finding at high frequencies over millimeter wave. So what kind of technology can be used for direction finding at such high frequency band? That is our question, right? Okay.
일단 그 7.5
For 7.5 gigahertz and above, there will be signal sources at such high frequency, but there are not many as of now. So as of now, 7.5 gigahertz is enough for now. But if it goes beyond that, it would be signals will be collected only in the very close proximity. In the military application, well, you have the technology to do direction finding for 40 kilometers, but it would require very expensive equipment. In the civilian area, if you do direction finding above 7.5 gigahertz, the cost will go up dramatically. And you cannot go far. Therefore, as of now, considering the cost, the need or benefit of going beyond 7.5 gigahertz direction finding is not so strong. But we could if we don't mind the cost.
So his answer is that we already have enough technologies for direction finding at high frequencies, but at this stage there is no demand on direction finding at high frequencies. So that's why the current system conduct direction finding less than 7.5 gigahertz.
My question was because we are talking about the commercialization of the 29 gigahertz for 5G. So how we will commercialize the 5G and we don't have the monitoring stations that is capable for direction finding of illegal work in these frequency bands. Thank you.
Yeah, so I would like to add one comment for your question. So E3, I'm working with ETRI in Korea, and ETRI has developed direction finding and spectrum monitoring system at 28 gigahertz. It was 2 years ago. So I think you can refer that development. You can find some information very easily on internet, or if you want, I can give some information about our technology. Okay. And Mr. Kim from OMPM, do you have any other comment about this question?
Thank you for the questions. Actually, I'm not a techie savvy, so I couldn't give you another state-of-the-art technology for the direction finding for up to millimeter waves and over. But from my experience, I think that there's RF sensors available. So technically, it's possible to
do the direction finding for the kind of frequencies. So and then we can combine the AI and big data systems. Then we can expand our coverage in terms of the geographic and also the frequency ranges as well. So soon, I hope to see get things done for these kind of challenges. Thank you.
Okay, thank you for your answer. And the second question is about regulation for drones in Korea. So I think this question can be answered by E3. Samjung? Okay, yeah. Mr. Shin from Samjung can answer this question, please.
According to my presentation, I already included the Aviation Safety Act of our country. So if you want, I will give you a full text about our regulation. And I hope you can find the answer. And if you need another question, I will answer to your question by email. Okay, so.
Okay, yeah, Mr. Gang first.
I add up the answers. And in South Korea, based on my knowledges, drones weighing over 2 kilometers should be registered to in our government systems, database systems, to fly in permitted areas. And regarding the frequency bands, most of the frequency bands in South Korea for drone use is unlicensed band, except one drone control frequencies. The control station is licensed and is in the 5.03 gigahertz to 5.091 gigahertz, as in the ICAO frequency, same as ICAO recommended. Okay, that's it. Thank you.
Okay, so Mr. No, yeah, you can answer, please.
I'll explain more about Korean drone company. Yeah, there are some Korean drone company, but as I know, it's not very popular in the world now, but yeah, still there is. And also, Korean company usually make a drone for harvesting and for entertaining. So yeah, there are industrial drone, which is very big one, and also there is a small drone, which is for entertaining. So, and also nowadays many drone companies are increasing. So yeah, there will be more drone company in Korea in the future.
Yeah, okay. So the answers are enough? Okay. Then do you have another? Oh, yeah, please.
Thank you, sir. Myself, Belaid Hussain, came from Bangladesh. So first, my sincere gratitude to CRMS to arranging this type of forum. And also thanks to all panelists. So my question is to Kumin. We also know that your drone industry is growing rapidly. So do you have developed any technology or any equipment to identify or neutralize the guided drone, which is not are used in spectrum? Please.
So you are talking about stealth drone, right? Yeah, so they don't use any radio frequency, so we cannot detect radio communication. So you are talking about drone identification for stealth drone, right? So is there anyone who can answer this question? It's very difficult to answer.
I'm sorry, but we don't have that kinds of solutions because I present as presented in my presentations. Some drone identification module should be attached to drones, and then these devices send or broadcast some information messages, and at the ground side, some ground identifiers catch that information. However, you recommended the systems, we cannot gather some information. So that is out of scope of my developing. But in the future, I hope that that kinds of technologies will increase, and then hope to get some information. Okay.
Yeah, and for another information, I would like to introduce another technology that is has been developed by KAIST in Korea. So they published a paper about drone identification for Stealth 1. So their technology is detecting spurious emission from RF system in drone. As you know, drone cannot use radio communication, but at least they have to use GPS system to find the location itself. So there is very weak emission from GPS receiver. So they presented a technology to detect such spurious emission. That is some electromagnetic wave emission. So it is a very interesting technology because they cannot use radio communication, but at least they have to use some GPS system, so we can detect the stealth drone by detecting, by receiving such spurious emission. Of course, it is very difficult because the signal level is very weak. But I think that is a very good try to detect stealth drone. And is there anyone to answer this question? Yes, please.
스텔스 드론을 탐지.
Detect and track down stealth drone. Well, there are three ways we can detect drones. First, through radar, we can detect. Second, we can find a way through optical. The third is scanning, and then we can do the direction finding. So there are three ways. But as you mentioned, in case of the stealth drone, the third methodology, the way we do is make it impossible to find the direction finding. Now, first of all, the shape of the drones, and optically, if we can detect the drones, this is the preliminary detections. And in order to prevent that, electric dome will be the second way. So we can trick GPS, because they use GPS, and we can trick GPS, and then we can protect it. And currently, these technologies are commercialized in Korea, and we are using the technology.
Answer? So the answer is okay with you? Okay. And do you have another question on the floor? Okay, yeah, please.
Thank you to the panelists. My name is Akira Robert from Republic of Uganda, East Africa. I thank the panelists for such interesting presentations and contribution. Majorly, I have three questions. My first will go to my friend in Romania. I've listened to the experience you're going through rolling out the satellite monitoring system. I've also, for the last 2 days, had quite an interesting tour of the Korean system, satellite monitoring system. And I think one of the points I picked out is, I think, one of the 5 in the world. This goes basically to underscore the technology put in, the kind of investments put into developing a satellite monitoring system. This also goes to tell you that this is not the kind of project every country would get involved in, because it's long term, involves a lot of technology and money, capital. And it's quite interesting to hear the experience you're going through. And based on your expertise with ITU and your cooperation with other countries, my question is this. Is there a way or a system where other countries can benefit from monitoring systems seated in developed by other countries? For example, you are developing a monitoring system. Is there a way another country that can benefit from what you're doing, and rather than rolling out their own system, they can probably use yours or part of your system to do the satellite monitoring in their respective countries? My question then goes to I think Samsung. Samsung, I realized you are now basically playing a significant role in the development of 6G technologies. Previously, at the beginning of communications, 1G, I think 2G standards were basically being led by operators. Then as the technologies grew, the equipment developers came into play. That's basically Huawei, Ericsson, and so on and so forth. Now with 6G, we are seeing the device manufacturers, mobile phones, are now taking a major role in the development of technology. What does this tell us? Does this then tell us that now mobile operators, the device providers are soon to be the operators we've been seeing, in such a way that probably in the future we're not going to look at the SK Telecom, but we are going to be working with Samsung in order to enjoy the telecommunication services? What is your look into the future, 6G and onwards? My other question is to the drone. Basically, there are 2 small questions in one. The first question probably would go to the CRMS, especially in terms of managing, how did you, I've forgotten the word, managing a drone system, especially around the airports. We know very well GPS is a fundamental service to the airlines. But at the same time, you also have a drone monitoring system in the airport. So my question would be, how are you coordinating the interference between the drone monitoring systems and the airlines within the airport? The other small question to do with drones, to my friend developing the drone identification system. I liked your analogy about what US and EU is doing, especially requiring drones to now identify themselves. My question is there a universal protocol or standard that has been developed and shared with manufacturers in such a way that now in manufacturing a drone, it's a requirement to input this protocol? So it's not about just the drone, it's also in building a protocol within the drone that wherever it is exported to, it is a default behavior of all drones, in such a way that the system you're also developing is standard and can be used in any country? Those are my simple questions. Thank you.
Okay, it's a very long questions. So, so you have 4 questions in total, right? Yes. Okay, so we had better answer your question in reverse. So your question about the drone system. So the first question is, do we have any drone management system, especially at airport in Korea? Am I right? So is there anyone who can answer this question about drone management at the airport in Korea at this time? Okay, I don't see anyone. As I know, we deployed drone detection system at the airport, at Incheon International Airport. It was about 1 year ago. So we deployed several drone detection systems to protect very important facility like airport. Already one, but as I know, we don't have any nationwide campaign to prevent drone attack. So it is now ongoing to make regulation and to develop technology. So one of them is presented by Mr. Gyumin Gang from A3. So that is my answer to your first question about drone. Is that okay with you?
Okay. What I understand from your contributions was the way the drone system works, drone detection system works, is in such a way that it blocks the GPS signal.
Yep.
Am I correct?
Yes.
Now, the same GPS signal is also being used by the airlines coming to the airport.
Mm-hmm.
So my question is, when you block the GPS signal, then what happens to the airline that needs it?
Okay, so is there anyone who can answer this question? I mean, GPS blocking is a very common technology to prevent drone attack, but in case of airport, all airplanes use GPS frequency at the same time. So it is very hard to interfere GPS frequency because it can affect the safe aviation, right?
Yes.
So can you answer that question, Mr. Yoon?
제가 간단하게 설명을 좀 드릴게요.
Yes, please.
인천공항
In the case of Incheon International Airport, they use radar technology. They don't use GPS blocking. As I've mentioned before, when you block GPS, it would be a threat to airline safety. So they don't use GPS at the airport. They're looking for another technology. So they're not using GPS.
GPS jamming is not being conducted at the airport because it can put the airplanes in danger. Instead, we have radar detection system to monitor drone activity near airport. Okay. And your second question about drone is there any standard or protocol to manufacture drone in Korea? Am I right? So I think Yeah. Mr. No. Who's going to first?
My concern is drone remote identifications. As I recommended in my presentations, in my talk, ASTM in the United States has already made some message formats. The document number name is F3411-19, or the recently updated version is 22. And also in the ASD STAN in Europe has made a message formats such as drone ID, location informations, and the timestamps, etc. are included. But the FAA in the United States, US, and Europe also they mentioned that the broadcast message should be broadcast using unlicensed band, but specified the special communication standards. For example, the IEEE 802.11 should be used, and you must include that kinds of the standard. But they didn't not specifically specify, but they just recommend. In my concern. Okay, that's it.
Okay, Mr. No, would you add some comment on this question?
And as I know, the DJI, which is a big company about drone, they provide their protocol for some company who detect a drone. So we can use that protocol, but we have to buy for that protocol. And also it's not maybe what you want, but as I mentioned, our system can identify drone with analysis spectrogram. It's not same as you said, but we can classify what company of drone is here now. So maybe you can, we can use that method to identify a drone. Thank you.
Okay, in summary, other countries already have regulation to certify drone before production, such as European countries and America. They already have such a regulation. But in case of Korea, we have a recommendation, but it's not a regulation, right, Mr. Gang? Yes. Okay, yeah. So we have just some recommendation to certify and register drone before production, but that is not mandatory at this time. Okay. And your third question is about 6G communication. So you asked I guess you are asking about 6G application. Am I right? So which application is being considered for 6G technology? Am I right? So I think this answer can be this question can be answered by Mr. Lee from Samsung Electronics. Could you please?
Okay, thank you for the question. And actually, there have been many discussion defining which application will be mostly used in 6G era. And there are many such proposals, opinion from many different countries and companies that in 6G era there will be many immersive application that supports such as hologram or a digital twin. So with based on the AI technologies and sensing technology, while utilizing the best amount of the data. So I think those kind of application could be main innovator for new communication. Thank you.
Okay. So he described three applications of 6G technology. So immersive extended reality and digital twin, and another one. What is that? Another one?
Hologram.
Hologram. Yeah,
Hologram, yes.
hologram. Yeah. So Samsung considered three applications for 6G technology, 6G application. Okay. And your second question is about international cooperation. So you are asking, is there any procedure, international procedure to support spectrum monitoring system to the country which is required to deploy? Am I right? Yeah.
Yes, basically to do with satellite monitoring systems. Yes.
Okay, satellite monitoring system. Okay.
Yes. International cooperation, satellite for rolling out and developing satellite monitoring systems in different countries.
So satellite monitoring system in international satellite monitoring cooperation.
Yes, please.
Okay. So I think Romanian can answer this question. Mr. Lufu, can you answer this question?
Thank you very much for giving me the opportunity to discuss about this important topic. First of all, there is not possible to have a good space monitoring without international cooperation, because different from other kind of terrestrial communication, space communication is globally by definition. Therefore, the main instrument in defining international cooperation is by concluding memorandum of understandings. This is the legal instrument between administrations. For instance, when an administration establishes a satellite monitoring system, the first of all is the need for an international recognition, and maybe the first step is to develop a memorandum of understanding with ITU. But next, there is the need for horizontally concluding memorandum of understandings with other administrations. Being in different parts of the world, it's extraordinary, for instance, to have, why not for Korean satellites, to have a view not only from the hemisphere where you are located, but also from European hemisphere. And on this way, for instance, if there are several administrations that are exchanging actively data about monitoring maybe the same satellite, it is very useful for designing, tuning, and preventing interferences that could occur and surely will occur. Now we assist to a very crowded usage of the satellite communications. To have or to find a gap where to deploy new systems is very hard. And without having a satellite monitoring system placed not only in your country, but also in other countries, it's compulsory. I want also to stress the fact that in the past, maybe all the global network, all the networks were sought to serve globally the countries or regions of the world. But now, due to the evolution of technology and of the demand from the user side, there is a need to a shift to what I can say national approach, or national satellite networks. But such networks has also need for support regarding the satellite monitoring in different countries. For instance, we would like to have a conclusion of memorandum of understandings when we shall have our monitoring system in function with Korea, with Japan, because we are in different parts of the world. But also, we'll be very happy to have such cooperation with African countries that are in the same IT region. And maybe it's very natural to have a regional development of the satellite system and to understand and to coordinate our efforts in the best way. For instance, we are very interested in the development of the satellite monitoring system from Oman. And now I heard about this evolution in Qatar. We are very interested because if we can identify some issues that was solved by this administration, we shall move swiftly. Putting different sensors for monitoring is difficult abroad, because abroad you need a special, as I can say, agreement from other country to put your infrastructure on that specific country. This is very difficult. Maybe it is better that each country develop its own system and next to develop a network of communications in real time in such a way that each country building its system will aggregate in a global satellite monitoring system. This is maybe the next step that has to be developed. In the past, only the very developed country could afford to have a satellite system and a satellite monitoring system. But now, technology are evolving and also the market is evolving. Therefore, first of all, there is a need for a legal instrument, a memorandum of understanding, and next, there is a need for an operational link, maybe in a network of satellite monitoring systems, satellite national monitoring systems. This is my idea. I don't know if I replied to your question.
Okay, thank you for answer, Mr. Roof. So in summary, there are several activities to cooperate for satellite communication, to monitor satellite communication already. But several leading countries already have such a system. But the problem is that the developing country require such a satellite monitoring system because these days many countries wanted to have a satellite communication system. So he stressed that we need international cooperation to monitor satellite communication and to reduce interference between satellite communications. So that answer is enough? Okay. So we already have passed our time limit. So I think we can receive a very short question, one question. I don't see. Okay, so now it's time to close our GSMF 2022. So I would like to appreciate all of you to attend here, and also the people online attendance. And I wish our foreign guests to have a safe journey home. Before closing this forum, I would like to ask a closing remark to Mr. Sang-Eun Lee of CRMS, because at first day you did opening remark already, so I think you can close this forum officially.
Thank you very much, Chair. And then I'll be very brief because we are quite running behind the schedule. So let me thank all of your efforts and then active participation for this forum. Like yesterday, we see great presentations and question and answers. So once again, I could be more convinced about the future development of the Global Spectrum Management Forum. And then also, I hope that all the participants in Korea, here in Korea, and then from Romania and Bangladesh and other participants via the online platforms. So I hope that you will have a good takeaway from this forum. And then so we could make this platform for international cooperation, and then for the, to share our knowledge and experience in the domain of spectrum management will be really great benefit for not just for our country, but for the international community. And then with that, so I also wish great success for the FIFA World Cup Qatar 2022, because this World Cup event is a really great, peaceful event in such a very hard time these days. So, and then we could see that how much Qatar government has prepared for making the event successful in just in the domain of spectrum management. So we are very we feel very safe for sure for enjoying the Qatar World Cup. And then so yes, once again, thank you very much. And then lastly, I should appreciate to my CRMS steps and then RAPA, Radio Promotion Agency, and other organizers who devoted and then also who paid a lot of energies to make this forum wonderful and successful. Thank you very much, and then have a pleasant trip back to your country. Thank you.
Yeah, thank you, Director General, Mr. Sang-hoon Lee, for closing remark. So it's time to close this forum.
All right, thank you very much. Shall we give another round of applause to the panelists and the moderator? All right, we'll conclude the Global Spectrum Management Forum 2022. Thank you very much for staying with us until the very end of our program. We sincerely hope that you found this forum very meaningful and worthwhile. And I do hope to see everyone in next year at our next forum. Please enjoy the rest of stay in Korea or have a safe trip back home. I'll see you next year, everyone. Have a great evening. Thank you very much.